Right, so hello wonderful people of the internet. Welcome back to another episode of Simuleo. Shadow Misha, Taucraft, hey, thanks for being here. And anyone who might be lurking in chat, hey, thanks for coming in. Right, so this intro took twice as long as my normal intro because right when I started stream, I was like, you know what I'm going to do? I'm going to post on Twitter. And I also thought, hey, I've got two monitors now. How about I put Twitter on that screen, right over there, the one that you guys don't see. I was like, that's amazing, let's do it. So I tried to log into Twitter on Firefox, right? And I hadn't logged on to Twitter on Firefox on this machine before. So it was like, okay, give me your account. I was like, great, here's my Google account. Turns out that even though my Twitter account is associated with my Gmail account, it is not directly linked to my Google account. So it tried to set up a new username, which was like @SchlossJames. And I'm like, no, I have a Twitter. Like, you don't have to create a new one for me. But I had to go through the entire process of creating a new Twitter. I was like, okay, now that we have that, we need to deactivate the account. Except because it was done on my Gmail account, I didn't have a password for it. So then I had to create a password by resetting a password that didn't exist. But then, after resetting it, somehow, I was like so frantically trying to start stream that I had forgotten the password that I needed to reset it onto. And so then I had to reset the password again. And then finally, I was able to get rid of that Twitter account, create a new Twitter account. And then I was like, finally, I can now tweet. So then I tried to tweet. And I then was like, oh, wait, let's get the exact, link to my Twitch stream. So I went to, Leos Labs, I grabbed the link after writing most of the tweet. And then Twitter was like, oh, let me refresh the page for you, shall I? By the way, that means that your tweet's going to be deleted and you're going to have to rewrite it. So I was like, screw it, man. Like, if you're making this much of a problem in order to just post a single 100-character comment on Twitter, what is going on? Anyway, by then, the Knowledge Fellowship had already tweeted that I had went live. So I just retweeted that and said, hey, we're doing ASCII stuff. Feel free to join. Man, it was a mess. I've never had that much trouble just posting something on Twitter. My gosh, it was insane. That happened to me not too long ago. It was a pain. Yeah, I mean, I don't know what was going on. It was just everything that could have gone wrong just went wrong. Okay, an update on the drama since yesterday. So, number one, I don't know how to put this, but 2 days ago, I didn't stream. The reason I didn't stream was because my wife and I, had to go get our residence cards. Now, we're not allowed to leave Spain without the cards, but we can't, we're allowed to leave Spain, but we're not allowed to get back to Spain without the card. And my card won't be coming in for another 40-ish days, which is December 30th. I wanted to go home for the holidays. I think after today, we've kind of just decided we're not going to do that, which is both a blessing and a burden. I mean, basically the point is, I will hopefully be streaming throughout the month of December now. We'll see how that goes, which means I now have presumably more time to work on the next project. And let's talk about it because I'm actually incredibly excited for it, despite the fact that I was very tired yesterday for some reason. So I'm doing what I can to be less tired today, but you can't just flip a switch and all of a sudden be less tired. You know what I mean? It's something that you have to work on and stuff like that. So for that reason, I will probably be bringing back the Swoleo's workout routine or something like that in maybe an hour or two, just to kind of get the blood flowing and kind of get back into the rhythm of things. We'll see how it goes, Right. Let me go over here and let me start talking about some stuff before going any further. And just kind of explain what the premise is, what we're doing right now, why this is actually interesting at all to begin with. Move this over there, that over there. And I need chat as well. Again, guys, if you have any comments, questions, concerns, ideas, anything like that, just feel free to let me know. So yesterday, I said we were going to be working on photomosaic research. Whoa. I'm sorry. It's not, we were going to be working on photomosaic research. Another problem that's very, very much related is ASCII art generation. And the reason it's related is because, if you look over here at ASCII Aquarium, you can very clearly tell that this is a swan. But clearly it wasn't just a picture of a swan turned into ASCII. Some person created the ASCII art, and then after creating that art, basically warped, what we perceive as a goose into ASCII characters, right? So they took a picture and they recreated the picture in ASCII using the tools that were available. They kind of extruded what is a swan into, what can fit in, 256 characters. And so because of that, there's actually some very difficult questions you have to ask, like how exactly do you modulate the shape of the object so that you can appropriately represent it in this graphical regime, all these type of things, right? So that all goes into the field of, I'm going to call it shape matching, which is not exactly right, but some people have done shape matching algorithms in order to make this work. But essentially the act of, showing that this circle is actually a circle, even though it's a representation of like a bunch of ASCII characters that look something like this, right? So this is ASCII circle. Forgive me that it's like poorly drawn. And then this is the actual circle, and detecting that these are the same object, ultimately changing the circle so it can fit the ASCII art style. That's all kind of in the same regime. So that is a very difficult problem. That is just not simple to solve in any way, shape, or form. There's one paper out that does some sort of, they say is real time, but it's one of those things that it's not really real time. It's like half real time type of things. And those people, they say they can do the structural ASCII art in like real time, but they really can't. So what is the actual interesting bit here? So the reason I've combined these guys both is that there's actually another type of ASCII art that people are very familiar with, which is like the density-based approach, depending on who says it. But essentially, it's just the act of taking an image and basically creating a bunch of colored ASCII characters that fits that image. So for example, if I go over here, I'm going to pause this for a second, CD into videos. What do I have here? Let me do mplayer, Arcane Algorithm Archive. Sure, that'll do. And I'm just going to full screen this guy. Sure. So here what we have is one of my YouTube videos. But, it's done entirely in ASCII. So you should be able to see my face in a second. That's part of the reason I created this YouTube channel. Ooh, it's a bit slow, isn't it? There I am. Hello. We're the same person. But ultimately, this is kind of the thing that I'm thinking about doing. Now, there's a bunch of like limitations to this type of ASCII art in that, if you do a smaller version of this, let me just play it here. It's not exactly me anymore, right? Like you can still tell from a distance it's supposed to be a person. But for the most part, you run into limitations with it, right? So this density style rendering versus the structure style rendering are the two different types of ASCII art you can create. I'm interested in creating a hybrid between the two by basically using a Sobel filter or maybe a full canny edge detection scheme. Actually, in fact, there was another paper that used like a semi-edge detector scheme that probably we'll use in the end to create a structural art that we fill in with the density-based art. But that's actually long-term, like we're talking about 3 or 4 months in the future. What I'm doing now is actually the first step of that, which is just photomosaic research. So just as we saw in the previous image, you can replace any image with just a bunch of ASCII characters that are colored. You can also replace every like little bit of the picture with a bunch of other pictures, and that's called a photomosaic. There's a bunch of different ways to do this, and I've been reading up on a bunch of papers on how to do it. But I think the ultimate goal here is to basically get a video out at the end of this year, doing what I believe, and again, this might not be entirely true, but what I found is the first ever 4K photomosaic video. Okay, now here's the thing. There are other types of photomosaic videos, right? But these are not exactly what I want to do. So if we go to, how do I put this? So let's say you have the image of a flower, right? Here's your image of the flower, right? There is a type of photomosaic video that basically has, here's your flower. I'm trying to draw one. That basically has this flower picture stay constant, but has each little block here, here's a video, here's your guy in the video, has each little block here actually change with time. So here the guy's, I don't know, moving or something. I'm just kind of like pretending there's a video here, right? So the idea is that the image stays constant, or even the image changes very slightly, but the videos themselves change, right? So this type of photomosaic video has definitely been done before. What I'm interested in are two kind of caveats here, two new things to the photomosaic research that haven't been done before. And the first of which is making it so these frames in the videos can all come from the same source. So, no, that's not exactly what I mean. Okay, let me try to rephrase this in a different way. So journal, new page before. What's new? That's the question. What is new about this? What's up? What's new? Here we go. And let me actually put the music back on. Okay, so what's new? Let's talk about how photomosaics are done, because honestly, it's not particularly complicated. I think most people can figure it out pretty well. Let me grab any image. Yep, here's an image. Perfect. All right, I'm gonna scale it down a little bit. Here's our image in here. Okay. So creating a photomosaic is basically the act of splitting this image up into a bunch of little pieces, you know, so we split it up into a grid, right? Something like this. Now, obviously the grid's gonna be more defined, but this is just kind of what we have for now. And so we take this square here, let me see if I can do this in maybe a different color. So if we take this square here, right? We know that this square is predominantly black. So what we're going to do is we're going to replace it with a predominantly black video. Now, how do you do that, right? Obviously, at this stage, just a simple replacement is not too difficult. The reason photomosaic generation is complicated is because, well, where exactly are you getting this video from? So where does this come from? Right? So that's the obvious question. Where does it come from? In my case, I could imagine maybe creating a 4K 60 frame per second video where each frame, like each photomosaic tile, comes from another set of videos. So it could come from maybe 1,000 different videos with, you know, let's see, 60 frames per second, about a minute. I don't know, we'll say 10,000 frames per. So we're talking about like, you know, millions of different frames, right? That you have to sort through at any given point in time. And so the reason this is complicated is because finding the best black video to put in there, the best frame from a video to put into that tile is a very complicated process where you've got to sort through a million different elements. Now, look, a million element sort on the CPU might be something that people do all the time. I really don't know. But on the GPU, doing this type of sorting, of binning, of figuring out how to find the ideal like block is actually quite complicated. And that's why, you know, when you see people doing, you know, photomosaic videos, they usually do the easier thing where they keep the image basically static. And then what they do is they look through a series of videos, not frames from videos, but videos themselves, and kind of create like what you could say is like how black or how white the video is on average, and then they put it in there at that stage. They then do a bunch of little cheats that I'm not really happy doing, but people will do, where they take the videos and then they impose like an intensity on there. So for example, if I had a video here, well, this tile is mostly blue, but there's a little bit of black in here, right? And so what I would do is I would say, okay, well, we have this frame that's mostly blue, but we're gonna intensity shade it. So anything that's black in the actual picture will also be black in the video. So they remove bits of the video to make it so it's more in line. It's more in line with the actual image you're trying to represent. Now, it is a bit cheating, and it's kind of like a last resort that I'll do. But, you know, the question is, if I want to do this kind of photomosaic research, what do I think I can do that's new, that people haven't done before? And I actually have a few different ideas. One is kind of doing this sorting faster by using a type of histogramming known as multi-split. Now, again, I do actually need to go through multi-split and learn it more in depth. Right now, we don't really have a good implementation of multi-split, but it's something that I'm interested in doing. And that should enable us to basically color quantize our image based on, I don't know, the top 256 colors or something like that, and then split the tiles into buckets that represent that color, right? So if we do a color quantization, creating a series of buckets, and then multi-split all of the frames into these buckets, we then have fewer elements to sort. Ideally, we should be able to do an exhaustive sort on each bucket. I don't know if we can actually do that or not, so we might have to create some some sort of like almost dynamic programming greedy algorithm to solve the problem for us. And for that, I actually thought about using some sort of gradient descent. Essentially, I've got a bunch of different ideas that I want to just throw at this problem and see if we can solve it. Again, it is already solved, and people have in principle created videos like the one that I want to create for a photomosaic in 4K, but they kind of cheat a little bit. Like, for example, what I want to do is make it so, this tile here that's supposed to be black, well, we can find the ideal frame to replace it with, or we can kind of fuzzy find a frame that will work and flip between a bunch of different frames that will work so that when you average all the frames together, it looks more black. This is something they do with ASCII video art, where they have certain characters flip between similar characters to make it so if you have like 60 frames per second or something like that of ASCII art being played, you should in principle be able to more accurately represent that block, And so there's a bunch of little things that I want to do here. I just want to try. For this, I'm actually going to ask you guys a question. So for me in particular, there's two bits to this, right? There's the easy, I say easy. So there's the hard bit. It's going to be hard. And this is going to be creating a real-time photomosaic, we'll say video, we'll say HD photomosaic video, right? This, again, as I said before, is still new. It's still something that people haven't done before, but it's a stepping stone to something that I consider to be harder, which is creating I'm going to call it high quality instead of high definition, but we're going to say creating HQ, high quality ASCII art. Again, by combining different types of ASCII art together, the structural and density-based ASCII art. I had thought about a bunch of different things that we could do here, like creating like a 4K ASCII video, which is silly, but ultimately I think the ideal thing to do here is just go where my heart's saying. And the trick of ASCII art, the trick of all photomosaics is, representing an image at a scale where you have fewer tiles. Like, what's the minimum number of tiles that you need in order to represent an object, right? And so even though, I always have the tendency to want to be like, oh, let's go bigger, like better, and all this kind of stuff. I think the actual solution here is not to go bigger, but to try to accurately represent objects in a 24x80 terminal screen, like you can with, for example, the ASCII command. You can clearly tell that this is a train and stuff like that. And so I want to be able to create high quality ASCII art. Ideally, I want to be able to just read in my video and directly plot that out into the terminal. At the very least, I want to be able to put in an HD video, like a 4K video, and compress that down into a 24x80 ASCII screen in real time. And by real time, I mean if a frame takes 1/60th of a second, it should also take 1/60th of a second to render it. Now, this is a very difficult problem. Like if you saw from the video I just showed, if you do a lot of, ASCII renderings like that using MPlayer, VO, CACA, or whatever, which is, what I usually use for ASCII art, you'll notice that it's just kind of a bit slow. My GPU is not particularly fast. It's a GTX 970. I do need to upgrade it, but it's just something we need to fix, So here's kind of the way I have this set up, and this is where I want to ask your opinion on. And actually, let me take a step further before asking your opinion. So both of these, right, lead us to basically playing with better histogramming methods, right? Right. And you might be asking, histogramming? You might be asking, why is this interesting? Well, the reason it's interesting is because it leads us into a bunch of other stuff, like, for example, the fractal flame becoming a fractal compression, right? Which then hopefully gives us some time to also look into a bunch of other really interesting things here. Essentially, the creation of our high quality ASCII art should allow us to kind of mess around with affine transforms in such a way that we can create like an affine transform field and stuff like this. It gives us a second to play with a bunch of these structures that we'll eventually use for real groundbreaking stuff, like the fractal compression stuff. Again, I called it physics without data, but this is essentially using the fractally compressed grid, you could call it, to do physics simulations. Would be quite cool. Data, all this kind of stuff. That's kind of stuff that I'm moving towards. In fact, I have a list of like really interesting projects that I want to get to. And even though, yeah, sure, ASCII art isn't necessarily on that list, well, I mean, it is actually on that list because I find it really interesting. Even though ASCII art doesn't actually help so much with a lot of this, it does help me with some of the goals. More than that, it is publishable. Now, I'm not going to say it's the best publication ever. They're not really great publications. So I think my video is lagging again. Give me a second. Let me fix that. But I think it will be, I think it will be good enough, and I'm pretty excited to see. I'm pretty excited to see where we go. A stepping stones for something great. Yeah, that's exactly what I'm looking for here. So, sure, I know a lot of people may not be as excited about ASCII art as I am, but I will say, man, it still seems like it's lagging a bit, but whatever, I guess it's fine. But I will say that for me in particular, I've always been fascinated with ASCII art, and I've always wanted to be able to do it. So this is kind of scratching an itch for me that, I put in the notification that it's a lifelong dream for me to become, part of my terminal. And that's actually kind of true. I've always wanted to be able to like create high quality ASCII art. So this is like one of those like, dream research projects for me that I've always wanted to do. Is it actually cool for a lot of people? At this stage, I'm tired of caring what other people think. I'm not going to make videos that are educational anymore. I'm just going to make videos that I'm like, hey, this is sufficiently cool. And like I said before, a few videos ago, for me, the coolest thing that I could possibly do, like, the most entertaining form of content I could possibly create, is a research paper, right? So the goal of the video is to be like, hey, this is super cool. And then my hope is that after people look at that, they're like, oh, actually, I'm more interested in this. Let me take a look at the paper, or let me take a look at the algorithm archive or stuff like this. So that's kind of where I'm going. Okay, so here's my naive, stupid question here. Journal, new page before. Maybe I can do this on like a Twitch. Isn't there like a poll or something I can do here? I feel like there is. This? Nope. Add a stream marker with description. What is a stream marker? Oh, I see. So it's just, okay, that's quite clever. So it's like a way for me to, like more appropriately check. I'm just learning Twitch settings right now. Like later on, I can take a look at it. Midlife settling. It's actually not midlife settling. I think it's the opposite of that. I've been, throughout my life, I have always kind of just done what I thought other people wanted me to do. It's like, hey, I make the YouTube videos that I think people want to see because this is what I think people like. But now it's like, screw it. I'm not going to make videos other people like. I'm just going to make videos that I actually want to see, which means, I'm not going to click on an educational video because I already have a PhD. But I will click on a video that's like, hey, here's something you haven't seen before. And I can guarantee you haven't seen it before because it is a new field of research, and providing a enticing way to get people into research, I think is the ultimate goal of anything I do here, right? It's trying to be a stepping stone into research, right? And so for that, you need one, a good hook, which I'm hoping the YouTube videos are, two, a way to get you from the hook to the surface, or the boundary of human knowledge, or whatever you call it. And that's what the algorithm archive is. And then finally the surface itself, which would be the paper, so the idea is to hook and then pull you up and bring you to that surface of human knowledge. Wow. Okay. I'm being really metaphorical here. Also, what does the phrase hook, line, and sinker mean? Hook, line, does that mean you can cast the line out at this stage? I never really thought about that. Anyway, so here's my naive question. Right now, we kind of have a few different ideas here. So we have the real-time HD video photo mosaic and the creating of high-quality ASCII art. I am fairly certain that neither of these are particularly interesting for a lot of people. So what I'm going to do here is hopefully theme this after Team C's. And then down here, I'm hopefully just going to put it out in January and be like, whoa, here's the coolest thing you've ever seen in your life, because it genuinely will be the coolest thing I've ever done. I'm pretty confident about that. I'm really excited about that one. So, what was I going to do? So here's what we're going to do. I'm going to ask you guys basic questions. As I'm kind of going through the list of things that need to be done for this to happen, I'm just interested to hear what you guys' opinion is throughout that. The fish, when they bite, they might eat the whole hook, then some line, and then the sinker. Oh, I see. So you're trying to catch the fish. I got it. I thought it was like you have to put the hook, the line, and the sinker on, and then you can throw it out. I thought that's what it was. That would require a huge fish. Right. I guess so. I'm a bit confused. I am honestly one of the worst fishermen you've probably ever seen in your life. I caught like exactly one fish. No, not maybe another fish in my life, but I know how to fish. I was supposed to be teaching a bunch of Girl Scouts how to fish at some point. I didn't know how to fish, like literally at all. I did know how to fish, but I didn't know how to catch anything. So I showed them how to like put the hook on there and how to, do everything. And then I cast out my line as a trial to show them how to throw it out. So I did it actually a few times. But like on the third times I threw the line out, while I was demonstrating to all the Girl Scouts, like how to catch a fish, I actually caught a fish at that moment. And as someone who had like only caught like one fish in my life, this is like a crazy experience. Obviously I played it off, I was trying to be cool, but like, it was kind of crazy that like the only time I'd ever caught something was when I was demoing how to catch something, and trying to explain to them how unlikely it is that they're going to catch anything. Anyway, that was my fishing story for today. Come back tomorrow for more fishing advice from a guy who never catches fish. Right, so what do we actually need to get this done? So one, we do need high quality histogramming methods. Histogramming, which is something we've been working on before. But it depends on what you actually need to histogram. So the big problem here is not so much the histogramming as it is the sorting, right? And so what we're going to have to do is, one, get a good histogramming method in there. And two, we have to find some sorting method. Now, for this, I'm fairly certain what we want to do is a form of color quantization. So that we can create like kind of the bins of different, thumbnails and stuff that we need to work with. And then on top of that, we probably want to do some form of, I'm going to call it multi-split, which is again a type of histogramming, but it just doesn't go the full way. It doesn't like split everything into like small bins. It splits them into kind of big general bins, which is what we're looking for there. But I'm going to add something in here with redundancy. Now, depending on how this goes, I'm quite interested in doing a third method here, dealing with, some people use genetic algorithms for this, but ultimately we do need to implement the genetic algorithm method, because the genetic algorithm method will be the benchmark. Like, they implemented it using genetic algorithms, but I'm convinced that's not the way to do this efficiently. The fact is, they did a photomosaic algorithm. They claimed real-time results. It was very dubious as to whether it was real-time or not, but they claimed real-time results using a genetic algorithm. So we have to implement that. But if the sorting and the color quantization and the exhaustive search, doesn't exactly work, I guess it's a local exhaustive search, then I also want to do this with gradient descent. I have an idea of how we could do this by using a little bit more GPU memory to make it work. So kind of the list of things that we need for the histogramming method is here. And of course, all of this has to be GPU accelerated. There's just a bunch of things to do here. And after all that's done, we can then finally get our photomosaic stuff done. And once the photomosaic stuff is done, journal, I'm going to do a new page after, so I can just scroll down, I believe. So then once we get the photomosaic stuff, we can then move on to the ASCII art, where we start talking about, one, shape matching, and two, I'm going to call it an affine field. I think it's actually called something else, but that's what I'm going to call it. Right? And the idea here is if you have, like, for example, a circle and you need to represent that in ASCII art, you have to kind of modify the circle so it's kind of more like hexagonal, so it would actually fit into the ASCII graphics or something. So the idea is you take some shape and you're kind of stretching it into something that can more easily be described by ASCII. The hope is that the affine fields here are what's like really novel about this work. It's not actually that novel, but the hope is that we could maybe use like an affine field as a like precursor, not a precursor, but like a what's it called when you have a like you have like a matrix and you're trying to solve said matrix like pre-solve or something, like a step before doing like stylistic art transfer or something. So for example, if you want to like turn into an anime character, you need to change your shape in a bunch of different ways to do that, your facial shape. And so what it could do is it could, kind of create a rough outline of how to change the shape first before doing the stylistic art transfer. So it's more, like it's a better overall fit for that kind of stuff. But once we have the shape matching and the affine field in there, hopefully, and this is where I'm a bit dubious here, but hopefully we can combine that with the photomosaic stuff that we did before to create, what would hopefully be high quality ASCII art, which is going to be the first time anyone has ever combined both different forms, both the structural art and the density-based art together. That's kind of what I'm hoping to do here. I've got an interesting way, I think, to tell the video. I think it will, I hope it'll work out okay. And yeah, that's kind of where I'm at here. So I don't know where to go now. So I spent some time after stream yesterday re-looking at the histogramming methods. The truth is, the histogramming methods are just a pain to do in parallel. And again, it's not even parallel. It's doing it heterogeneously with CPU and GPU capabilities. I was just running into a bunch of problems with specifically the CPU. I'm so used to GPU programming where you can assume that the thread number is high and all this kind of stuff, that when you go back to the CPU where you only have, at most, for my case, 16 cores to deal with, it's just a pain. So I might take a break from the histogramming and instead do some other stuff that we have to do, like a parallel implementation of color quantization, for example. There's some interesting questions here as to like how exactly do you represent an octree and stuff like that. Again, we're gonna have to get a parallel implementation of genetic algorithms, and we might take some time to look into multi-split papers and stuff like that. Okay, so I've been very dodgy on reading papers on stream, and the reason is that for me, like I said before, papers are like super enjoyable. They're like, it's like honestly my favorite form of entertainment. And I just can't properly explain or express that enthusiasm on stream. Every time I try to go through a paper, it turns into me like teaching people how to read papers. And it's like, that's not what I'm doing here though. Like what I'm trying to do is show you that like, hey, this is actually super exciting. And I don't know, I get kind of 50-50 on that. In addition, we run into like a bunch of copywriting issues when it comes to papers where technically I don't think I'm legally allowed to show a paper on stream. The only reason I'm doing it here would be, obviously for educational purposes. But more than that, the only reason I feel comfortable is because the videos are going unlisted on YouTube. So only people with a link can find them. So it's clearly not like I'm not using it for any monetary gain. But again, you could argue that the Twitch subscriptions, it's kind of weird. I don't really know how to label it. Essentially, I don't know if I'm entirely in the clear showing videos or showing papers on stream, which is why I haven't been doing it. But again, maybe I just start doing that. I think what I'm really trying to do is like find a way to just show all the cool stuff that I'm doing on stream, because every time I try to, I run into a block where it's like, wow, I just can't think straight, or, I can't figure out this thing. And then the moment I turn off stream, I figure it out. I'm going to be right back, and then we're going to go ahead and get started. What I'm going to ask you guys in the break before I get back is, what of the things I've talked about is actually interesting to you? Do you actually want to see me go through papers and explain, why this is interesting, how this is different than other papers, how it's, boundary breaking, all this kind of stuff? Would you rather see me doing more of the, like ASCII art or photomosaic stuff? Is any of this actually interesting for you? If not, I do understand. But I'm interested to hear what you guys' opinion are, your opinion is about this particular topic. Again, I'll be right back, and then we can jump right into it, I believe. Okay, Shadow Mishia says, I'm interested in the photo mosaic stuff in particular, but all of it sounds cool. That's good. But yeah, so just to finish up the discussion here, before really hopping into it, I realize I've been talking for like the past 45 minutes. Well, honestly, just 30 minutes or so. I really do want to find a way to show people like actually interesting research. And like the fact is, this isn't actually interesting research, right? Like you could argue that climate change and doing climate simulations is actually interesting research. You could argue that, doing quantum information is actually interesting research. But what I'm trying to do here is just show that like, that boundary of human knowledge isn't super far away and is actually really fun to look into. And that's kind of the whole purpose of not only this channel, the Twitch channel, but also the main channel. And it's stuff that I'm really trying to push. And so doing these, just kind of things that people haven't done before that are kind of off the beaten track, turning into ASCII, creating a video from every other video that ever was put out on Team C's or something. Like this type of stuff I think could be quite interesting for some people. Like maybe people get into it. I don't know. There's some other stuff that I'm doing, like for example, a 4D galaxy simulation. But see, the problem here is that this one is probably going to be a collaboration with 3 Blue 1 Brown, which we've talked about before. But the main issue with that is that I don't really see 2 videos coming out of this. Like it's going to be a lot of work, like an insane amount of work, like months of work to get it done. And like everyone else would try to milk that content. They'd try to be like, yo, I spent ages on this, but I kind of feel like, I don't want to talk about, the process of making content on YouTube, right? Because that's what the Twitch stream is for. And I don't want to talk about the technical details on YouTube because that's what the papers are for. And I don't want to talk about the algorithms on YouTube because that's what the algorithm archive is for. So YouTube is literally just 4D galaxy simulation. This is the first time this has ever been done. That's it. That's all you have to say. Just a video abstract. Everything else is everywhere else and is better served everywhere else, in my opinion. The point is to just talk about the big thing. Be like, hey, this is what we did. It took months of work. Here's all the stuff that went into it. If you're interested, go here. But, I'm not going to talk about it in this video, right? That's what, most people do. Like, most of the big content creators do. Like Mark Rober, for example. He doesn't talk about his engineering too much. He just says, here's a video montage or a build montage for 10 minutes or something. And maybe that's what I'll do as well. I'll be like, here's a build montage. Maybe like snap in and be like, actually, there's something really interesting that happened here. But for the most part, like, you can find everything that you're looking for on stream. Okay, so how are we going to go today? So today, again, there's a bunch of problems to solve. Histogramming is one of them. But I'm not burnt out for the histogramming problem, but I'm stuck. And so what I'm actually going to do is move on to another set of problems. I'm going to call it Mosify for mosaic, mosaic-ify. And then we also have another one, which is going to be ASCII-ify. So I'm going to start actually writing the package for mosify.jl. And we're just going to start hacking at it and working on that. So my hope for the end of the day is that Mosify has like a fully featured featured color quantization scheme. We've done color quantization a bunch of different times on this channel. At some point, I do need to put it into the algorithm archive, but it's one of those algorithms that's like so kind of fundamental. I kind of feel like, I don't know, like it's literally just an octree. It's not super difficult to do, but I do also need to put those data structures into the algorithm archive as well. As far as stuff to do, I'm hoping to have this video out before, I want this out by the end of December, so we'll say December, let's say 20th, 2021 is my ultimate goal for this. So as far as stuff to do, it's already Wednesday of this week, which is insane. But I'm hoping to get maybe this guy and this guy done by the end of this week. So some sort of high quality GPU enabled histogramming method, and then also the color quantization for Mosify done. And then we can go ahead and implement the genetic algorithm method, which is the current state of the art method to do this with. And then once we have the genetic algorithm stuff in, then I want to start working on the multisplit, followed by potentially a faster histogramming method, which we might need to just make things better. And then again, if I think we need it, we might also talk about gradient descent. Here's where, for me as a researcher, I feel like it's ideal to talk about gradient descent as well, as quickly as possible, so that we can really show the whole the whole scope, like be like, oh, there's also this idea, I just want to show people like everything you can do to speed up this process. But, on the other hand, my goal isn't necessarily to stop at mosaics. I also want to go into the ASCII art because I think this is actually a fundamentally more interesting question, and this is fundamentally more useful. So we'll see how we do the optimization in a bit. In fact, probably on modern hardware, admittedly I don't have modern hardware, but presumably on modern hardware, the genetic algorithm approach is relatively real time. But, we'll see. So let's go over here, Control C, and we're just going to go ahead and get this guy started. Now, it's been a long time since I generated a new Julia package. So give me a bit of time to just kind of figure things out. So we're going to do CD projects, and I think I can just do Julia, and then I think I can just do generate Mosify. Okay, Control D, CD Mosify, and let's see here, over here, CD projects, Mosify. Now the next thing I need to do is probably move stuff over. So let's go ahead and move a license over. So we're going to CP. I'm just going to grab my Simuleos license. Simuleos, and then license.text here. Going to VI license.text. Make sure it's not 2015, it's 2021. Sure, should be good to go. And now let's go here and just do git init dot, I believe. Git branch. Oh, git init. I think it's just git init. Okay. Git status. Git status. Okay, git branch. Oh, we don't have any branches. So I don't remember. Do I need to git checkout -b main? Git branch. What? How do I not have a main branch? Anyway, let's go ahead and add the remote on GitHub. Oh, and it should be called mosify.jl. What is it called right now? It's called just Mosify. CD backup directory, and let's go ahead and move Mosify into Mosify.jl. All right, CD into Mosify. Okay, and let's also add a README while we're at it. So here we're going to do Mosify.jl, and we're just going to say this project aims to create high quality real-time photo mosaics. Yeah, sure. Development happens in the development branch. Check there for updates. Okay, this is just because the way I like to do it is just keep everything in the development branch until I see, until I feel like it's good enough, and then I move it on to the master branch. That's just how I like to do it. I think everything's added, so let's go ahead and create it on GitHub. So we're going to create a new repository, and we're going to call it mosify.jl. Okay, down here we're going to do, the description is going to be high quality photo mosaics in Julia. All right. We're actually going to ignore all of this right now and just create the repository, and then we're going to push to it. So let's do git remote add origin here. Sure, should be good. Perfect. And now we're just going to git add dot git status. There isn't going to be anything in this right now. We'll work on it in a bit. So let's go ahead and do git commit -m adding initial package. All right, git push origin main. Okay, then I'm going to create a development branch, and we're just going to work off of that. Git branch. Perfect. Git checkout -b development. Okay, here's where my Julia knowledge is just gonna fail me miserably because it's been a long time since I did any of this kind of stuff. Where's my water? So forgive me if I'm just like slow and bad at this. We're just gonna see how it goes. Okay. Yeah, let's just see how this goes. So we're in the development branch. The first thing I need to do is add different repositories that we're going to need. For this, I assume we're going to need the image repositories and stuff like that. So I'm going to play around with it a little bit in Julia and see what we can do. So we're going to do Julia -- project. Okay, messed up. There we go. Now we're going to do add kernel abstractions. Probably CUDA, and then CUDA kernels. Then probably images, I believe. And I think this is all I need for now. I always forget with Julia packages whether we have to include... It always comes with a project.toml. I'm pretty sure we just need to read in the project.toml. I don't think we also have to commit the manifest.toml. Let me double check. I always forget. Let's go to kernel. Let's pretend I can type, which I cannot, but let's just pretend for like 10 minutes here. GitHub, kernel abstractions. I think they just have the project. Yeah, it's just project. README, license, .gitignore. Okay. Let's go over here. And while we're working on this, let's just go into vi.gitignore. Well, actually, let me do an ls really quick. Now let's go into vi.gitignore. And I'm just going to ignore any star.dat files because I use .dat for my data files, and then manifest.toml. All right, git add.gitignore. And the next thing, I think we have images already loaded, so I'm just going to mess around a little bit and make sure everything works. I think I should have using images. I should be able to do like create image view and stuff like that. So another thing, I don't know if people a long time ago, I actually had this idea of creating a like an ASCII video game. I was actually super excited for this thing, like a story-driven terminal-based game. You know, I had a whole bunch of ideas for it. I was actually really excited for it, but I never really got done with it because I don't know, it was one of those projects that just didn't feel big enough to do. But if I can create like really high quality ASCII art, like just on the fly, I think maybe it's something to return to, you know? It makes the process of creating that video game way easier in a way, and that's quite nice. So I might come back to that, like maybe this time next year. Okay, using images. What is it? Image view, I believe. Image. Isn't it just view image? Maybe. Okay, so I'm trying to remember how to use images. It's been a long time. So img is equal to image. I think I'm just going to create like a random distribution. So img is equal to image of rand of 10 by 10 or something. Rand image. Yeah, maybe it's... Can I just plot it? Wait, this is me forgetting completely how to use the image library. Give me a second, I'll figure it out. What do we actually have? Image dot images dot. Oh, okay. Well, this is gonna be a pain, isn't it? So I know we have a bunch of RGB pixels. Oh, it's been such a long time. Can I do rand of RGB? Let me see if that works. Oh. Okay, and let me just do view, or rather image is gonna be equal to rand of RGB, why not? 100, 100, and let's see if we can just do view of img. I am show. I am I thought it was just view. I might have to go into an older project here and figure that out. Let's do that really quick. So let's go here, open this up, make it a new terminal. This again, and we're going to cd into projects, Quiltify. In fact, a lot of this source code might be stolen from Quiltify. I don't know if you guys remember this project. You guys probably don't. But a while ago, I actually tried to make, basically turn any image into a quilt. I still kind of have the idea of creating like a quilt video or something. I actually really want to. But let me just show. So let me go mirage dog.jpg. Okay, wait, where are we? Here. Here. So for example, we could turn images into these kind of quilt textures here. Which you could just like show as, you know, quarter tiles and stuff like that. It was actually a lot of fun to do, but I couldn't quite get it to work. You know, I tried a bunch of different things, and I never really got anything that looked nice for a quilt texture. I just kind of messed around with it a lot, and ultimately just said, okay, you know, here's our color quantization thing in progress. Yeah, I never really figured it out. So we might go back to that in a bit. Let me just go ahead and take a look at the source code here. ls ls source, and let's go into cd source, ls again clear, and let's go into ls one more time. Go into vi, maybe quantize.jl. Actually, let's just go into vi quiltify.jl. We're just using images. Isn't it IamShow? No. IamView? No. Maybe I have another package that we have to do. Add image view. Yeah, maybe that's what it was. Maybe I could only save images and I had to output them differently. Again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. Again, I'm hoping today we can get some sort of color quantization method working, and we can go from there. Yeah, we'll see. Yeah. Okay, so we'll let this do its thing, and then I think we should have the IamView or IamShow command available. Yeah, and we'll see. That is one thing about Julia syntax. Like, I'm kind of used to Julia from like Julia 1.3. And so, like, I know a long time ago, like, everything worked completely differently. View of IMG, does that work? IamShow of IMG? Come on. Wonderful, we got our image, I think. Wow, what an amazing image. This is just the best image I've ever seen in my life. And if you disagree, you're probably right. Okay. Let me create like some sort of smooth gradient and just save it just so I remember how the image command works. Okay, so we're gonna say we want 1,000 by 1,000 image, and we're just gonna say img is gonna be equal to RGB. Wait, let me double check. RGB of 111. Does that work? Yes. So what I want to do is img is going to be equal to RGB, and then I'm just going to say red, green, blue. So we're just not going to have any green. It's going to be a gradient from white to red and then white to blue. So it's going to be oh, how do I do this? RGB of I divided by 1,000. Well, let's do 1,024. Why not? 0 J over 124 for I, maybe J equals 1 to 124, 1024. Is that going to work? I don't think so. How do we do double for loops? I'm pretty sure we can do that. For I, J equals 1 to 100. Okay, how do you do this? For I, J? Double for loops. I don't even know what I'm looking for. Okay, there we go. Every time I try to remember the syntax, I always forget it. So it's for I equals 100. And then that should work. Okay. Let me do IM show of image. It's a 1024 by 1024 image, so give it just a second. All right, that didn't look bad. And now we can just go ahead and save it. So I think we can just save image as, we're gonna call it check.png. Maybe it's check.png and then image. All right, there we go. So we've got our image. I'm gonna put it in the upper left-hand corner just to say we did something today, and then we'll go from there. Let me open up a new terminal, cd projects, Mozify, ls here, and now we're just gonna do mirage check.png, and we're just gonna put that in the upper left-hand corner. 1 second. Move this here, and this over here. Okay, perfect. Good, so we have that. I'm not saying it's pretty, but we have something. We have at least gotten the image libraries to work. Sure? Sure, okay, doesn't really matter. Okay, so we have that working. Let me go ahead and add .png, .jpg, all these type of images and stuff to the gitignore file. So we're gonna do star.png, star.jpg, star.gif, star.jpeg, and again, all caps versions of those as well. I don't know if those are actually caught by, no, they won't be caught by the gitignore, but I can't think of us using any other types at this point. Let's go and right quit, git add.gitignore. Okay, so we have everything kind of sort of loaded. Now I think we can start working on the Julia files themselves. So Control D, cd to source, ls here. We have mozify.jl. I'm going to create a new file, which is going to be called, I guess it's just going to be called quantize.jl. And what I might do, because I know we have the quantize file already in quiltify.jl, I might just grab that and go through it and see what needs to happen. In some sense, I think today we're going to kind of figure out how to do an efficient implementation of an aux tree on the GPU. I think that's really important, not only for this project, but also for the project that we're doing later with 4D galaxies. We'll see how that goes. Okay, so what I might actually do is just check over here, vi quantize.jl. And what do we have here? Quantization may fail if no colors are for a box. HSC color space. I'm not convinced this is efficient code, but it is a start. It is a start, and let me see, what are we even exporting here? Naive bin. Okay, that's fine. We'll get through it. Divide aux tree. The problem is the creation of an aux tree is obviously something that's not, it's just not easy to do on a GPU. So what I might actually do is look up some papers on efficient aux tree generation on the GPU and see what people typically do. Man, there was a paper I read the other day. Oh boy, I was really pissed off. Well, I wasn't pissed off at the paper. I just found it was super funny. Like the paper was like, you know, GPU acceleration of X methods, you know? I don't remember what the methods were, but I remember reading it and being like, oh, wait a minute. Those methods are incredibly difficult to do on the GPU. I'm really interested to see how they do it. Turns out, when they said GPU acceleration, they were talking about another part of the method. And they did the stuff that was hard on the GPU just on the CPU. So they're like, we did this on the CPU, and we did this part on the GPU. And I'm like, dude, I came here specifically for GPU optimized methods, and you give me CPU methods and claim that the other part is GPU, therefore you can claim the whole paper is GPU accelerated. It's like, man, that's just clickbait. Like that is prime clickbait. Okay, what I will do is I will copy this over, and I'm gonna try to just see if it works. So let me go over here, vi quiltify.jl. What are we exporting here? It doesn't look like we're exporting anything. Okay, so what we're gonna do is just cp quantize.jl over here. Cp projects quiltify source quantize.jl here. And now we're going to go into vi mosify.jl, and we're just going to include that file. Include quantize.jl. Okay, let's see how that goes. I should hopefully get a quantize command, and the first thing I'm going to do is quantize check.png and see if that actually works. Then I'm going to go through the file, and we're just going to kind of notate it and see what we actually need to do to get this to work in parallel, if we can do anything at all. The answer is we should be able to do stuff. I just don't know what exactly that stuff is. So, we'll get there when we get there. Hold your horses. Calm yourself, Don't get too excited. Okay. So what am I doing with my life? We're going to do Julia _project over here. And over here, we're going to do using Mosify. I misspelled using. Give me a second. And over here, let's do vi Mosify. And I'm going to do using images, image view. And I'm also going to do down here using kernel instructions. And then CUDA. 1 second. I think that's right. And then we're going to say if has CUDA GPU. 1 second. And using CUDA kernels. Okay, using Mosify. Wonderful. I misspelled kernel abstractions. Yeah, it's Julia, not Java. Abstractions. Wait, what? Syntax module. I misspelled chotomate right here. Try it again. All right, letting it precompile. I should have done using revise before this. In fact, I will do that. Let me just see if it precompiles, and then I'll close it and then use revise afterwards. Does not have data structures in its dependencies. Okay, sure. I'll just resolve the packages. Give me a second. Resolve, and then we can go from there. Yeah, okay. Now I'm going to do Control D, Julia, using revise. Yeah, fine. Add revise. And then I'll use revise, and then we'll load Mosify, and then go from there. Okay, let's see how this goes. I mean, the truth is, I've got a lot of work to do if I'm going to get this done by the end of the year. I know, the end of the year is 40 days away, but man, this is just a lot of work to get done. Using Mosify. So, any progress is progress, But I'm also very glad that I split this up into the photo mosaic stuff, because before that, I was going to have to spend a lot of time, just doing the fractals. It would not have been possible to get a video out by the end of the year, or any project out by the end of the year, for that matter. I thought Resolve would do that, but apparently not. Let me just go ahead and add data structures, because apparently we need it. I don't see where we need it. Oh, I think I see where we need it. Add data structures. Okay, so we should have a mosify.quantize. I wonder if we need a separate repository for quantize.jl. Let me see. I don't think, who would have had... I don't think anyone has a color quantize version, or a color quantize repo available. I'm sure some people have color quantize repos available in Julia. That's fine. But I think here, let's just try to check to see if our quantize thing works. And then I might... Let's actually take a second and look up what people do for color quantization on the GPU. I'm actually quite interested to see what people do. I don't really see how to optimize the aux tree right now in parallel. Let's see if we have mosify.quantize. I do. So I should be able to read in image is going to be equal to load. Using images and image view. And let's just do a color quantization of that image that we have up there, check it, see if it's actually color quantized, and then write that out, just to see if we have a working quantize function. And then I'll commit that, and then we can start talking about how we actually need to optimize this for GPU programming. So img is going to be equal to load of check.png. Perfect. Okay, not perfect. I added an extra space in there. I'm just going to do imshow of img just to make sure it loaded correctly. I don't see why it wouldn't, but you know, it's fun to double check things. Give it a second. All right, looks good to me. And now let's try the mosify.quantize. I'm going to first do methods of mosify.quantize. Looks like it takes in image and color number. So we're going to do mosify.quantize of image. And then let's do 8. I remember this taking a while because of all of the sorting and searching to do. So we'll let it do its thing. I think this is going to be the slowest part of the process. So if we can do an efficient color quantization, like that's already a big step forward. So let's do imshow. What did I say it was called? I called it. Oh, I didn't call it anything. img2 is equal to this. Okay. What do I want to do next? What I want to do next is. What do I want to do? I actually want to check my stream really quick. I know this sounds really weird, but I want to hear. Let me do imshow img2. Let's see what this looks like. Oh, that's not what I was expecting. Let's try doing 16. Well, we know the quantization function is broken at least. Oh no. Oh well, we'll figure it out. Dang. So we can't just... Yeah, that's still broken. It's only showing 2 colors, not 16. Let me try with a different image. I'm going to copy one of the images over from the Quiltify directory. So let's cp projects. Projects. Come on. Quiltify. And then let's do... It doesn't matter. Pride. Oh, no. cp projects, Quiltify, and then pride.jpg here. Let's go over here and let's do img3. It's going to be equal to load of pride. Hello? Oh. cp pride.jpg, package directory. Okay. Pride.jpg. I'm going to show it really quick just to make sure it worked. imshow img3. Okay, perfect. There's our pride flag. And I'm going to do mosify, img2, img4 is going to be img3 with 16 colors. Let's see what it looks like. Already it looks like it's doing better. We're not getting a bunch of nothings, so that's good. And let's just do imshow of img4. Yeah, this one worked. I'll save out the 2 different ones so you can see the difference here. There's something clearly wrong with our color quantization code, which is fine. We can work on that in a second. So let me just do a save of pride2.jpg. And then we're going to do img4. Okay, over here we're going to do mirage pride.jpg. So here's the original one. And here's the color quantized. Hello? Okay. Oh, remove. Then we're going to do mirage pride.jpg. So here's the original one. And here's the color quantized one. So you can clearly see the color quantization is working. Basically what it's doing is it's limiting the number of colors that are available at any given point in time. I'm not sure why this one isn't being color quantized correctly. That's something we need to look into. But we do get something kind of working with the quantize function. So outside of working on bugs, I might... outside of working on bugs, I might go ahead and commit what we have for quantize.jl. Now, this is again leading me to believe that maybe we actually want a separate repository entirely for color quantization, like, quantizify.jl or something like that. Quantify is not color quantize. I don't know. C quantify, whatever it is. We need to find some like package name for it, and we'll work on that. But depending on how involved the color quantization implementation is on the GPU, we'll see how it goes. Right. So the next thing I wanted to do was actually increase the volume on my end, and do something really quick where I just actually listen to my stream, just to see if the music is too loud or something like that, because I feel like it might be. Oh, oops, I did the wrong one. Let me go back over here. Yes, that. Make that. This over here. You don't see what I'm doing because it's behind my face, but that's okay. Okay, let me check something really quick. Come on. I think it's probably fine. I mean, I can decrease the music if I want to. All right, sounds good. Okay, so I'm going to drop this down again on my end. Okay, so what are we doing next? I'm going to look up efficient implementations of color quantization on the GPU. See if we can find anything. I don't know if we will or will not, but it's something interesting. So let's do, let me actually go to Google Scholar for this. Color quantization GPU and see what we got. Techniques of GPU-based color quantization. That seems promising. Color quantization, this is done in what year? Am I dumb? Where's the year? 2010? Okay, ResearchGate. But only one citation, really? You would have expected this to be more citations than that. 1 second. This is over here. This is... what? Oh, I see what happened. It opened it up in Firefox. Right. It downloaded it though, so let's just go back over here and open up palettes. Ocular downloads palettes.pdf. Okay, let's see what this is. This is going to be in what year? Tell me, please. You're not telling me what year. Please. Like, give me a year. Is this like 2003? Or is this like 2021? Because there's a big difference between those 2 years. All right. It's just going to give me a PDF site. This is from... No way. It still doesn't give me a year. There's not even a year on this citation. Matthew Sebastian. What? Okay. I'm going to look up this guy, and we're going to look for... Oh, obviously there's too many citations. There must be a PhD student somewhere. Probably this guy. Or this guy. H-index of 8. Probably can search through this guy. And we're looking for GPU color quantization. No year! Oh my gosh. Okay, that's fine. I checked the BibTeX, actually. So the BibTeX, here, there's no year in the Bib... Oh, I see what you mean. The BibTeX itself, right. No, there's still no year here. Title, author, book title, preceding International Conference on Computer Graphics, Visualizations, and Computer Vision. I'm pretty sure that one happens every year, so that doesn't help me either. Okay, I assume the paper's probably fine, but the fact that it doesn't have a year is sketching me out. I was hoping for something that was done like in the past 5 years or something. It comes up since 2017, but again, I think that's just because there's no year on index, which again is super weird, but it's so garbage when they don't put a publication date. Well, so the truth is, maybe this is a good time to talk about it, right? Like, there was a post on Twitter. By the way, ACQ Edits, thank you so much for following. There was a post on Twitter a while ago that basically said, you cannot trust any papers that were published in the past 5 years. That's what I challenged that statement, but that is what the statement said. And their reasoning was that physics, which is a discipline they were looking at, is constantly evolving and changing. And therefore, any theories or discoveries that were made in the past 5 years have the chance to be uprooted or changed. And they're not wrong about that, right? Like, it's totally fair that, like, you know, things that were written within the past 5 years are more likely to be updated or something like that. But frankly, I don't think any like major theories published in the past 5 years are any more likely to be challenged than papers published 10 years ago, right? Like, you know, like for example, AI. AI was one of those things that was super big in like the 70s and 80s. Then it died down and came back again recently when we found out that we actually had the computing power to do AI stuff. You know, so machine learning, for example, is one of those things that is now super popular because we have the computing power for it, right? So, you know, the AI stuff published in the 80s, now people look at it and they're like, oh, that's kind of a bit garbage. But, you know, at the time, you know, this 5-year arbitrary date is kind of not, I don't know, it was a weird argument. But in my opinion, you can't really trust papers that were published beyond 5 years ago either, because papers published beyond 5 years ago are subject to being outdated, right? Like, you know, if you see a paper published 5 years ago, then you really need to like double check its forward citations. For example, this one's cited by one, and see, hey, when was this published? So this, for example, was published in 2020. Surface-based out-of-core processing explorations at high-resolution images maybe is interesting. But anyway, my point is that, like, you know, when I'm looking at papers, I tend to look at the publication date to see how relevant it is and see how many citations you get. So, for example, here, you know, I was asking myself, hey, how much do people actually want an efficient GPU implementation for color quantization? Turns out the answer is not very much. You know, we see 1 citation here, 7 citations here. Meanwhile, if I go to photomosaic GPU, we don't get too many more citations. Since anytime. We really don't get too many more citations at all. But what you will see is ASCII GPU. I think we get quite a few. Yeah, so 27. So you end up getting more citations with like ASCII stuff than anything else. Thanks for that. Let's see what we have. I had an idea to finding the DOI and see if that had a year. Found the year 2019. Oh, nice. There you go. That's what you need. Well, I'm ranting about what age means in research. Oh, I forgot the L. Someone's actually doing the work. Wait, what? Anyway, fair enough. 2019. That's fair. Its only citation is from 2020, so I imagine that makes sense. Let me go back to color quantization on GPU. And maybe what we do is we just read through the paper. I mean, I'm seeing if there's anything else here. GPU color quantization. There's this one. There's no citations since 2010. It's in the URL. Oh, let me try one more time. Let's go here. Open this up. Paste. Enter. Oh, WSCG 2019. It's right there. 2019. I got it. I understand now. All right. Holy, I thought that terminal on the right side of the screen, I just realized it's chat. Yeah, it's chat. Hello. It's just that we've been kind of quiet today. Like there hasn't been too much discussion. So because of that, it's not as clear that it's chat. Taking this for GPU-based color palette mapping. Maybe this is useful. I'm actually curious as to why we don't have so much data about GPU color quantization. I would have thought that we would have actually had a bunch of papers on color quantization because, you know, you think GPUs are super good at visualizations and stuff. Maybe we want video stylization? Let me take a look at the citations here. Cited by 2. Image effect creation, GPU acceleration of best features-based rotoscope. Okay, here's what I'm going to do. I'm actually going to open up that paper that we just downloaded, and we're just going to go through it and see what we can do. Let me go over here. CD back a directory. Oh yeah, let's take a look at this one as well. But I figure a lot of this stuff would probably be done in shader logic, right? K-means, sure, K-means is useful. Parallel K-means image clustering for image quantization, right? Sorry about that. Let me move this over here. Let me grab this guy and let me look it up on Google Scholar. And then I'm going to actually move, oops, messed up. 1 second. And then let me move these over to the papers to read. I'm going to look this up on Google Scholar. Where am I? I am here. Paste that there. Perfect. Let's see what we got here. Yeah, that's not so bad. Actually, where is it? Parallel k-means clustering for image color quantization. Where is this paper? Parallel what? People garbage handling color in the first place. It's kind of up to you how you define color. Textures don't have to store images. It can be whatever you want. That's fair. Weird. Okay, we'll look at this in a second. Let's, I can't even find the paper. Okay, I'm going to go ahead and do make a directory papers, cd to papers, and we're going to move downloads. Well, obviously it's k-means. This guy over here, there was one more. Move downloads. What was the other one called even? Let's go here. What was it called? It was called Firefox. Give me my downloads. Here we are. Are you not going to give me my downloads from recently? Or are you going to give me my download today? Palettes. That's what I'm looking for. Okay. Palettes.pdf. Not a paper, it seems. Someone implemented, hosted on GitHub. Oh, okay. It's weird that it's not cited, though. Anyway, we're going to take a look at these actually locally really quick and just kind of mess around with them a bit. I'm happy to do this kind of stuff. It seems fun. Yeah, let's just see what people say. Because the thing about papers is, you find one paper, and the point of an individual paper is to kind of open up the door to other papers to find, right? So let's go and do Zernal PP. Let me do palettes first, since that's the one that we found first. Scroll down, move over here, and let's just see what we can find. Again, the truth is, people are not apparently too interested in color quantization, which I find interesting, and I'm suspect as to why. It could be that people just know that GPU representations for color quantization is slow, and that's why people aren't into it. And so people have other methods to do it with. That could be the reason. But I suspect there's another reason for it that I'm not familiar with, right? So for example, I wanted to use color quantization as a way to create a series of bins for my photomosaic generation. But also photomosaics are one of those things that people don't talk about very much because it's just a poorly optimized problem. It's one of those kind of like boundaries between art and computation that, it doesn't actually serve too much of a purpose outside of just like people's curiosity, and I probably wouldn't have been into either if it wasn't for the fact that I want to become an ASCII character. Like that's my ultimate goal in life. I have nothing else I want to do except for become, I just want to host myself on a 24x80 terminal. That's what I want to do. Okay, how many pages is this? 7 pages? Let me okay, 7 pages. Let's just kind of hack at it, shall we? Zoom in a little bit more, I think, into here. And let's see what we can find. Magenta. Okay, this paper represents a GPU-based approach to color quantization by mapping of arbitrary color palettes into images using lookup tables. Okay. Lookup tables, sure. Let's actually do highlighter mode, shall we? Lookup tables here. Let's also make the highlighter pink and then make it, here we are. Lookup tables here. Then we're going to change here and just do LUT. Okay. For different types of LUTs, their GPU-based generation, representation, and respective mapping implementations are described, and the runtime performance is evaluated and compared. So you like libcaca? I like libcaca. I actually don't know if it's libcaca or not, but yeah, a lot like that. But the difference is I want to do both density-based rendering and structural-based rendering at the same time. So the difference between that is, so for example, if I open up the SL command, this is a structural-based image. The idea is you see the structure of a train, but you don't see an actual picture. Whereas if I do mplayer VO CACA videos Hatsune Miku, here you see a density-based image where you don't see the lines so well, but you see the characters and kind of their faces and stuff like that. So I want to combine the two approaches here, which I think would be the first time anyone's ever done that. But also I want to make it fast. I'm really interested in making it as real time as possible. And there's other things like that I'm actually quite interested in. This ultimately leads into faster fractal compression methods later on down the road. But I kind of see these as like little milestones to get there. I feel like that's cheating. Using color blocks is basically pixels. Right. I mean, it is basically pixels. And I do also feel it's cheating, which is why I'm doing it. ASCII tubers are the newest trend. Okay, video with it. Yeah. So we're going to do ASCII videos. Like, no doubt, it's going to be ASCII videos. We're getting there one step at a time. And to get that, we need color quantization. I've got a bunch of different things, but it's going to take months to get there, like months of work to get there. And so what we need to do is first start with the easier problem, which is photo mosaics, which is why we're talking about color quantization, all that kind of stuff. Once you solve the color mosaic problem, then it moves into density rendering via putting in certain ASCII glyphs, the same exact problem as the photo mosaics. But then the interesting question comes in, how do you actually reform the image that you're reading in such that it can be represented in ASCII graphics and stuff like that? It would be dope if it definitely will support color blocks. No doubt, it will support color blocks. What I want to do is basically take an image, form the image differently so it fits into ASCII characters. So I'm literally talking about like an affine map to change the shape of my face or whatever, so it more accurately can be represented in ASCII, and then density rendering that image. And I'm going to do this with a bunch of different techniques that I've been reading about recently. Like, I look, the thing is, I've mentioned this a bunch of times before, but I love reading papers. Like, I read like probably 50 papers over the past week. It's like, okay, you guys can't see here, but like just here, it's 1, 2, 3, 4. There's at least 20 papers in this stack, and then there's another 20 papers in this stack. And I went through both of these over the weekend, so it's about 40 papers, but some of them I didn't print out. I really enjoy just learning something new, and I've just been. The thing is, when I was at, I've mentioned this a bunch of times, but when I finished my PhD, I was at the end of my PhD. I went to MIT, and something about being at MIT just made it so I stopped reading papers entirely. In some sense, I stopped doing research entirely. I was focused entirely on software engineering, and it wasn't fun. It was just, don't get me wrong, I don't mind teaching. I don't mind doing software engineering, but the truth is my heart is in research. And even if this is just a really stupid little thing to do, at the same time, I don't care. Like, just doing any little bit of research that hasn't been done before is so just mesmerizingly amazing. It's like, oh, let's just do it. Like, this is amazing. Let's do it. I get so excited anytime I read a new paper. There was one paper. It was, oh gosh, it was the stupidest paper. Real-time photo mosaic image. No. Let me get it for you. It's all fine. Photo mosaics for QR capabilities. Oh, actually, I didn't read that one yet. Let me pull that one out. So the interesting thing about QR capabilities is they were able to hide information within a pre-existing photo mosaic, which I thought was interesting. How do you keep track and remember all of that? Do you keep something like Zettelkasten? I don't know what that is, so no, that's not what I do. Let me go here. Digital mosaics. Where are we? We're past that. GPU accelerated. Oh, this is it. This is it. Oh boy, this paper was so stupid. Oh, I hated it and loved it at the same time. Let me just find it really quick. Gosh darn it. Give me a second. Photo mosaic generation. I'm going to do it on Scholar. Photo mosaic gener. By rearranging subimages with GPU acceleration. Okay, this should find it, I believe. This one, there should be a PDF available. Let me see. Open. All right, here it is. We're going to download that guy, and I'm going to look at it locally. Ooh, it's taking a while to download. Ugh. All right. It should open in Firefox over there, but I'll close it and I'll look at it locally. No, actually, I can just look at it here. So let me do, let's do Cyril again. Downloads, downloads, photo, mosaic generation here. Okay, so these guys, it seems like a very promising paper. Like I mean, obviously I downloaded it and printed it out because I was like, oh, this is quite interesting. Photomosaic generation by rearranging some sub-images with GPU acceleration, right? So if you haven't seen a photomosaic, this is a photomosaic. You're essentially trying to recreate an image with other images. This isn't a good representation of a photomosaic, but it is a photomosaic. So what they did is they took the images from Lena over here, and they rearranged her to recreate this target image here to make that image there. What got me was how they did the rearranging. They literally just put Lena's image in there, and then they did bubble sort. They literally just took every tile and checked and swapped the tile, right? So they took tile 1 and tile 2 and they swapped it, and they said, is this a better representation of the image? If not, we swap it back. And they did that over and over and over again until the image looked okay. That's what they did. And you can actually tell like how this worked, because if you look at the image, clearly they did this, how do I put this? They clearly did this horizontally, because you can see the striations in the actual image here. So they literally just did bubble sort over an entire image, and that was their paper. I'm like, okay, man. Like, and then down here they try to like upsell it. Like they actually have plenty of discussions about like how this works and all this kind of stuff. And I'm like, okay, but like you literally just did bubble sort, man. Like you can talk to me all about like all of these graph representations and all this kind of stuff, totally fine, but you just did bubble sort. Like, what do you want to do? Where do you go from there? How did they measure if the representation was better? This actually isn't too difficult to do. You can just basically do a pixel by pixel, in this case, grayscale test to see, hey, how close was each pixel in the tile set to the actual representation of the real image. It's not so bad. But what gets me, it always gets me. Every time it gets me. Look at this here. Okay, please, if you do GPU programming, like I get it. Like 10 years ago, it was super exciting to show, wow, look at us. We've got a fast representation on the CPU, but it's even faster on the GPU. Oh my gosh, wow. But look. That's not a true representation of the difference in speed. Don't give me that. This whole speed up notion is just dumb. I hate it when people do this. They're like, wow, we're 100 times faster than the CPU. It's like, well, you're using different hardware. Of course you're going to be a different speed, Like, it just bothers me. They're like, wow, we got 78 times speed up. It's like, well, like, this isn't even a fair comparison. I get that I'm being a bit biased here, and that, like, quite frankly, I shouldn't get so irritated when people do this. But whenever I see this in a paper, I'm kind of like, probably the paper was not worth my time reading. How do they measure if the representation was good? Right. Anyway, I'm being super biased here. There was another paper, though, that was genuinely fascinating. Let me see if I can find it. I know I'm being super biased here, and I should stop looking at papers and stuff like that, but let me actually find the one that settled in my mind that we should do ASCII animations. And I will show it to you as soon as I can find it. Oh, no, this is the wrong folder. There was another paper as to how I keep track of everything. I assume that meant how I keep track of all the papers I read and everything, which I will talk about in just a second. I don't really have a good... I'll talk about it in just a second. Parallel framework for fast photo mosaics. What do we have here? ASCII art synthesis from natural photographs. Oh, that's a good one. ASCII art generation using the local exhaustive search on the GPU. Perfect. This is the one. This is the one I want to show you guys. Which metrics would you rather? Power consumption? No, what I would rather people do is not compare it to the CPU at all. That's what I would rather them do. I feel like anytime that you're doing a comparison between the GPU and CPU, what you're doing is you're showing off the GPU as being faster than the CPU implementations. But at this stage, and again, this could just be, one of those arguments that's lost to time, but at this stage, you kind of know the GPU is going to be faster. Giving you a speed up between CPU and GPU it's not really like an advantage. What you want is a speed up between GPU implementations, right? So it's like, right. It's like comparing a car to an airplane. Exactly that. Surely the airplane is 10 times as quick. Right, exactly. So if you're comparing two GPU implementations, and, that's fine. I appreciate these GPU implementations. But if you're in the field and you're publishing a paper saying that we're 78 times faster than the CPU, well, like I've already read 10 papers about, fast photomosaic generation on the GPU, Probably I'm on the GPU for a reason. Probably I need it for other material, right? And so like, giving me the speed up between CPU and GPU, I'm already sold on the GPU, man. You don't have to tell me to convert my code from the CPU to GPU. Just tell me how fast this is compared to other GPU methods, That's what I'm looking for. Anyway, I know I'm being super biased here and I should stop ranting about this type of stuff. Let me go ahead and remove all finished and let me go here and look up the one that's actually quite cool. And I'm just going to do this on Scholar. It should be ASCII art generation using local exhaustive search. Should be it. Should be able to grab this PDF as well in the same fashion. Open, sure. Downloads, yep. And let's just look at it. Zernal, PP, ASCII, downloads, ASCII, art. Rants increase. They always increase the viewer count. That's why I rant so much. Okay. Right, so there's this paper up here, ASCII art generation using the local exhaustive search on the GPU. Now, I've mentioned this before, but searching on the GPU is one of those problems it's just bad. You don't search on the GPU. It's just not designed for that type of stuff. If you have to bite the bullet, you have to bite the bullet. So using a local exhaustive search is already, I'm already thinking, this isn't going to be that great. But again, this paper was published in 2013. There are better methods that are out now. However, the key thing about the local exhaustive search is that if you're going to try to find, let me start a bit more basic. So if you look at this image right here, we have her nose right here. There's her nose. And then we also see her nose over here, right? Somewhere. I'm not actually good at this. But what you're doing is you're going through every pixel or every group of pixels on the original image, and you're trying to recreate or replace that with some sort of ASCII glyph, right? That's what you're trying to do. And so to create the absolute best image, you do actually need to sort through the entire domain, right? And so doing search, you need to search through the entire domain. So the only way to actually guarantee that you have the perfect representation or the best representation in ASCII is to do some form of exhaustive search, right? So the question is, how do you do that search as efficiently as possible, right? That's the question that it ends up being. As I was going through, these guys had some cool ideas, but here's the thing that I thought was quite cool. I would use patch match for this. Patch match. I'll take a look at this as well. Thanks for that, by the way. Go back over here. Patch match. I'm sorry about that. I'm now in Japanese mode. Patch match. Yeah, I want a paper on this. Is what I want. Oh, MATLAB. Don't give me MATLAB. Specifically mentioned as being non-local. Right. So let me go here. So what you see is, here's the original image over here, which is kind of something that you would expect from like libcaca or whatever. And here's their method over here. And you do see like a clear improvement. Oh my gosh, I can't find my mouse here. And you do see a very clear improvement between the two of them. And so it got me thinking, first of all, this representation over here, like, look at that nose. Holy God, I can't do this. Give me like a black cursor or something. Okay, that nose is like it's a very well detailed nose compared to the other one. My point is, like, you can see these fine details a bit better in their code, and that's quite cool. And so this is the one that kind of got me because I looked at this and I saw that might be that could be what it's actually for. But I saw that we have this image in here. The density-based, tone-based ASCII art is what it's called. I've been calling it density-based, and structure-based down here. And then I looked at papers on the structure-based stuff. Anyway, I got really deep into this stuff. It's super exciting, really, really cool. But I don't know. I find it really nice. I got really into it. I'm a big fan. There was a question up there somewhere. I don't remember who asked it. That Judar. How do you keep track and remember all that stuff? Let me talk about that really quick. So I don't know if this is about all the papers and stuff, but actually I've been reading papers since I was in junior high. To me, there is absolutely no more entertaining medium than the research literature, like YouTube videos, video games, books, movies. Like these are things that, for example, movies and video games and stuff like that I'll do with friends. I don't really watch YouTube too much. Like basically all I do is read papers, right? And so in some sense, I've always been, that guy who enjoys this type of stuff. So it just kind of clicks in my mind a bit better. But also I realized recently that like having a digital notebook to keep all my papers just doesn't work for me. I need a physical form. Because a lot of times, like if I'm looking for a paper, like I'll remember, like for example, this image on a paper or something like that. And sure, if I have a digital form, I'm not going to remember the title of the paper up here. I'm just going to remember that image. I'm going to be like, oh, I'm looking for this image, or maybe I'm looking for this image on the last page. Like it might not even be on the front page. I could just be looking for this guy, at the very back. And for me, I have not found a digital library that allows for me to easily search for images in the PDF, and also allows me to note take as effectively as I want to. Like there's just a bunch of, I have not been able to figure out how to organize my paper in a digital form. I've not been able to figure out how to organize my papers, plural, in a digital form to make it as enjoyable as having a physical copy of the paper available. So when you're asking how I keep track of it, I literally do it this way. I just have a bunch of piles of papers. So these are all of my ASCII and photo mosaic papers. Then I have my histogramming papers in another pile, and I'm probably going to split out the ASCII and photo mosaic into two separate piles in a bit. But that's literally what I do. I just have a bunch of piles of papers that I read through. I realize it's not the most... there's probably way more elegant ways to do it. It's just in my 15 years of reading papers, I have not found a way that's more just enjoyable, I do mean what I say. I said earlier that, I genuinely love reading papers, and it's something that I find incredibly enjoyable. And I stand by that. Like, it's part of the reason why I'm restructuring my YouTube content, I'm restructuring it so that the YouTube content serves a more fundamental purpose and doesn't compete with the algorithm archive. It doesn't compete with the papers. They're all distinct, different things. I wish someday I can write a paper. It's one of my goals for way too long now. My hope is that, people who are watching this stream will kind of realize that, it's not actually that difficult to get from where you are to writing a paper. It's not so far away. I draw Emacs, specifically Doom Emacs, for reading writings PDFs with images. Interesting. Yeah, I never thought of Emacs as a... So, right, my issue is again, I read 50 papers over the past week. How do I keep track of all 50 papers? That's the question. And I don't really have a super good way of doing that. If you're telling me that Emacs can act as a paper repository, that is quite interesting. And if you could give me a link, I'd be interested in that. Let me check the bibliography for this paper really quick. And see what we got here. 6 citations. Are you kidding me, man? You can use org mode and Doom Emacs to do it. Org mode. I'll look at it in just a second. I'm looking at citations. I'll take a look in a second. Real-time rendering 4th edition. Comparative analysis of the quantization of color spaces on the basis of Scilab color difference formulas. Real-time shading. Yeah, okay, let me just... Fine, we'll talk about paper reading a little bit. The problem is every time I talk about paper reading on stream, it ends up being one of those things that I'm super into it, right? And so I end up giving people advice, and they take it kind of as a mini lecture. But I don't really... 6 is bad. Maybe not in computer graphics, but at least in the areas where I read papers from, anything less than 40 citations is pretty rough, I would say. It means that you didn't do a thorough literature review before publishing the work. In my opinion, one of the most important parts of any paper is actually the bibliography, right? Because when you're reading a paper to begin with, specifically if you're new to the field, it's very unlikely that you're going to understand everything that has to do, you're going to understand the paper fully. It's very unlikely. There's going to be a few things that you're just going to have to look at. And you're going to have to abstract away the things you don't know to get the kind of overall goal of the paper, and then you come back to it when you have a better understanding of all of the nuances that you didn't understand at the start. So having a bibliography with only 6 citations, of which are predominantly general, just like books on, creating shaders and stuff like that, it doesn't bode well for the paper. I'm not saying it's a bad paper. It could be incredibly novel, such that it only needs these 6 citations, but I doubt that's the case. I have a sinking suspicion that they didn't do their due diligence with the literature review. I don't live in this world. If I don't take notes on something, I will forget for some reason. It's a bit annoying at times. I prefer to keep those notes online. I just struggle to take good notes. Yeah, I mean, I kind of feel the same way. Like when it comes to reading papers, I always jot notes in the filler space. What's it called? What is the filler space called between the text and the end of the page? The margins. There we go. I always write stuff in the margins and stuff like that. The reason I'm using Zernal on stream is just to show how that note taking happens. Let me open up this link, see what it actually does. Let's go here, remove all unfinished. Writing assignments in org mode, Doom Emacs. Source code embedding, UML diagrams, margarine. Not margins. Let me get some water. Sorry, I'm kind of thirsty. By the way, Paul Middick P, thank you so much for following. Really appreciate it. CLA YouTube searcher. Okay, I'll take a look at this later. Truth is, I'm so deeply in the cult of VI that I don't know if I'll look at it later. I'm not gonna look at it now, but I'm so deeply in the cult of VI. I don't know if I'm willing to use Emacs for anything, even if it is the best tool for the job, I'm gonna be right back. Give me a minute. I'll be right back, and then we will see if we can find. I'll look through this paper, and we'll see. Maybe the K-means paper is slightly better. Yeah, we'll see. All right, give me a second. I'll be right back. Okay, give me 1 second. I'm also going to change the title of the stream so it specifically says research in the tag here. Again, I'm slowly but surely trying to make research more of a thing that people do on Twitch. Look, I don't think I can actually do that alone, but I'm really hoping to get more researchers to just do live streams and stuff because I find it super interesting, and yeah, I just want to see more people doing cool stuff. I know that Twitch is predominantly a gaming website, but the truth is the non-gaming streams are the ones I enjoy the most. I think I'd be really into reading literature if it were not for the fact that I have issues with eye tracking, so it takes me forever to read anything. Like my eye will skip from one line to the other randomly. To be fair, right, like I also kind of have that issue, which is why I actually find I find papers easier to read than books, for example, right? Because usually it's written in this 2-column mode where like it's kind of easier for me to go from here to here than it would be if it was one long column from like here all the way back over here, you know? So what I'm trying to say is I 100% agree with that. I feel that pain. I don't like feel it as fully as you do, but like, do reading is really tiring. Yeah. See, this is something else that I've heard a lot. Like, I have said, and I stand by, that, papers are the most entertaining, like the pinnacle of entertainment. I cannot think of anything that's more engaging than that. Now, that said, almost every single person disagrees with me there. I don't think I've ever heard of a single person who has ever agreed with me with that statement. I genuinely find research papers to be the most engaging form of content that mankind has created, and again, almost no one has agreed with me on that. So, if you're a person that kind of prefers video content and stuff, like there's a bunch of video content creators out there that will probably scratch the same itch, like 3 Blue and Brown, Reducible, people like this. But I'm not going to do that because I don't like those videos. I'm not, well, they're fine, but they're not the videos that I want to see on YouTube. I want to see videos that are like, hey, this is fundamentally new. Here's this cool thing we did that you've probably never seen before. Here's why you haven't seen before. And, here's a paper. That's what I want people to do. Just be like, here's a paper. So kind of like 2-minute papers, except only talking about their own research type of thing. Okay, let me go ahead and close this. We'll take a look at it later. And let me look at the k-means. Journal PP k-means report.pdf. I'm going to take a look at the citations there, see if there's anything kind of more relevant. I'm really looking for like a review article or something. So this one at least has 10 citations. I'm taking a look and seeing what they have. Like what I'm looking for is a review article to go back to so that I can find like, some relevant paper for parallelization of color quantization. In particular, probably what I'm looking for is, color quantization is literally just an octree. So I might want like advanced octree generation techniques, maybe. We'll see. You'll have to agree that some of them are rather bad, but I'll agree that some of the science papers are pretty entertaining. The issue for me is that I also have I have focus issues. So the drier something is, the harder it is for me to keep myself focused. Would a chapter on tries be interesting for the archive? Tries? What do you mean? Oh, trees. We have tree traversal already in the algorithm archive. So I was going to extend that to octrees. The medication for that. So, okay, I hate that I keep doing this. Let me do journal new page before. Just very quickly, I'm just going to explain my point and then not going to delve into it too much. Let's say this here, I'll just draw a rectangle, is the amount of entertainment I get from a research paper. So I'll just say paper. Right. Just for another point of content here, this is probably the amount of entertainment, of enjoyment I get from, we'll say working out. Specifically, I'll say swimming. I really do enjoy swimming, so we'll put that down. This would be the amount of entertainment I get from a video game. Actually, it's way less than that. It's like down here. So we'll say VG for video game. And this is the amount of entertainment I get out of a YouTube video, just slightly more than a video game. It's not that much more. It's pretty much the same. My point is, and for the record, even the best YouTube videos are like just so much worse than even just average papers, right? I've never found a paper that I have not been just engrossed in to some extent. Now, look, sometimes when reading the paper, I can only understand like the literature review section or the references or something like that. But I genuinely cannot find anything else that is as enjoyable as like an average paper. I just can't. It's super engaging. And people are like, oh, it's super dry. I'm like, is it though? Because it's super engaging. You're never going to be able to find any other content on earth that has as high of an information density as an academic paper. It's just, you can't. It's not possible. And even the worst papers I found are just not that bad. nowhere near as bad as like the best YouTube videos, like just for me in terms of entertainment and enjoyment, that's where I'm at. And like, I know maybe I'm biased because I just spent the whole weekend just reading papers and I'd been missing out on it for a while recently. So, maybe, this will go down a bit, if you ask me again in a week, but it's hard. It's really hard to beat that. Let's see. Anything to say for us people that don't find useful stuff enjoyable? That's fair. Why is say I think I would enjoy reading literature if not for those issues, because I enjoy learning above most other things. Aren't there actual metrics for information density? Okay, to be fair, I might have been a bit hyperbolic. They're probably, like, for example, the reason I make math visualizations is because I do genuinely feel that you can get a lot of information out of a good math visualization. Visualizations on determinants and eigenvectors and in Monte Carlo, all this stuff is super visual, and having a quick 30-second visual will give you way more information than a couple paragraphs of text, right? That's totally fair. And so to some extent, I'm being a bit wishy-washy here, and, maybe I'm being a bit hyperbolic and talking about things that, it's an opinion, right? But, someone said, that I have to agree that some papers are bad. I'm like, okay, I mean, I guess some papers are bad. Like there are certainly some papers that have poor results. I mean, we just talked about a paper that literally just did bubble sort over an array. And it's like, wow, we have something new. Of course. Like there are papers like that. But even those papers you learn something from, like it's like, you learn something from them because they have information in literature review. They have information in the bibliography. You can still get something from them. Even the bad ones, you get something from. When I was in junior high, I started reading biology papers to start. And then I went into a lot of neuroscience, specifically EEG stuff. I got really into synesthesia for a time. Then after that, I started reading, some chemistry stuff and then physics stuff, landed on computational science stuff. I did history papers as well, super into Reformation and Counter-Reformation. I had so many different topics. I've read papers from all over. Like, it's insane. I say it's insane, and I'm talking about my own. Basically, if you count the number of hours I've spent reading papers, it's just way higher than the amount of time I've spent in anything else. And again, I cannot think of a single paper I've ever met that I didn't like to some extent. Even the absolute bogus ones in neurophysics that are like, here's a quantum, here's how quantum neuroscience works. I still liked them. You like them in the way that you like pseudoscience, but you still kind of like them, I don't know. So far, your stream has been pretty entertaining to me. Those papers have strong competitions. That's probably fair, right? Maybe I picked only entertaining ones, right? Doesn't PI have the maximum density, non-repeating infinite sequence? I don't know. Oh, you mean pi is in the constant pi? I had read the following for a class a year ago. Let's see, what do we have? No, look, obviously I'm biased here. No matter what this paper is, I'm going to be like genomic expression analysis, multiple Sri Loki. Oh, wait. Does this do string matching or pattern matching? Because if it does, that's super cool. Or like edit distance is what I'm thinking of. Anything that has to do with bioinformatics is super cool stuff in bioinformatics. Star is a gene known to be essential for test determination. Testes determination, but also transcribed in adult male tissues. Oh, interesting. The laboratory rat has... Oh, you kidding me? So you're telling me this is about rat genitalia. Wait. Has multiple Y chromosome copies of SRY, DNA sequence comparisons of other rodents with multiple SRY. You're telling me... Wait. Am I getting this right? Let me read through the abstract really quick. Let's see, what do we have here? A pi is base 64. Somewhere in there would be a story describing your life, but it wouldn't be mostly garbage. Are you saying my life is mostly garbage? Hey, Shidipto, how are you? Speaking of information density between videos versus text, what's your take on video journals? I don't understand. I don't know what a video journal is, but I don't know why you'd ever take a paper that's in text. We can talk about that later, but I don't... It's like interactives, I don't find interactives particularly useful. I find good, well-positioned videos useful, but I don't find like interactives useful, because if you give someone a game to play in the middle of trying to understand eigenvalues, they're just going to play the game. They're not going to actually learn about eigenvalues. Plus, you're giving them a huge space to traverse now when you want them to be hyper focused on understanding the one core example that you're trying to give them, Anyway, in general, I prefer to keep things to text because I understand text better than I understand other mediums. So if there are video journals, I kind of think it's kind of silly, but also like fine. I mean, whatever. If people get it better, that's what they get. Multiple Y chromosomes. Okay, so I'm going to ask a stupid question. What is Rattus norvegicus? Clearly, we're talking about male rats. I'm doing okay, Viking Coder. How are you? I hope you're having a wonderful day. Oh, and 1337, thank you so much for subscribing at tier 1 for 2 minutes ago. Let me go ahead and put a single cow in chat. I'm sorry, I missed that a few minutes ago. I think I got every other notification though. Great, thanks. I'm doing actually pretty well. Like honestly, I fluctuate a lot. I go up and down. But that's life, I am personally really excited because we're starting a new research project, and that's always the best time when you're starting a new research project. Like before life kind of, pummels you in the head and makes you realize you can't even implement histogramming on a GPU. Like this is the start, I think it's non-scientific name, like Norwegian rat or something like GAT. Anyway, so I don't know what it is about research papers. It could just be the way that they're written that makes me really enjoy them. But to be fair, there's a reason I stay away from bio papers, right? Like, it's not that I don't... the bio papers I read, I actually like, but I don't understand the jargon so much, so I tend to stay away from them, right? And so for me, I do agree that, certainly some papers are probably dry to certain people, but my argument is there probably is an area of research that is incredibly exciting for you. It's just that those areas that you've been looking at are not, right? And so it's kind of like, I always see it as like a video game, right? Like if you're like a level 1 player and you go into like a level 80 raid and people kick you because you don't know how to play the game, you don't go and say like, oh, the community of this game is awful. You legitimately had no experience in this area, and you tried to understand the topic that, or tried to do something that you had no skill in doing, right? And so I can't be here and judge a biology paper because I'm like level 20 in biology when I have to be like level 80 before I get to the end game or something like that. You know what I'm saying? Like there's a level of proficiency that I don't have in this area. So for me, biology papers are actually kind of interesting because it's like a look into another world that I know nothing about, but at the same time, can I say that I'm as interested in bio as I am in computational science? No, there's a reason I landed on computational science. I looked at a bunch of papers when I was younger and found that these were the ones that I liked best, What are good places to look for open papers? Oh, that's a good question. Let's go ahead and talk about that right now, shall we, since we're ranting about everything else. The archive. So there have been times, there's a bunch of different answers to this question, but there are times when I actually cannot look at the archive anymore. And the reason I can't look at the archive is because I get too incredibly addicted to it. So I always go to core new. I don't know why, this is just where I go. And I look at this and everything's amazing to me. It's like bag of tricks and a strong baseline for image copy detection. What is a bag of tricks? What does that mean? Image copy detection is of great importance in real life social media. What? Image copy detection. Oh, okay, so this could be used for anyway, I'm sorry. The point is every time I go to the archive, it's always the second link too, but also piano fingering with reinforcement learning? You kidding me? Wait. Is this what I think it is? Wait. I have to look at this. 1 second. I'm so sorry. I have to look at this one. Let me go to Zernal PP and let me go to downloads. And let me look at 2111, whatever. Here. Okay. Piano fingering with reinforcement learning. Let me scroll down. Oh, you... Wait. Let me just read the abstract really quick. And so it's a crappy paper. No doubt it's a crappy paper. But, what are they doing? They're teaching, I think they're teaching an AI to play music is what they're doing. Not a place, but this helps. Um, It's a piece of rat. Hey, you can do histogramming on GPU. It's just terribly inefficient. Oh, tell me, I've been hitting my head on that problem for the past 3 weeks. Histogramming on GPUs is one of those things that's like fascinating in so many different ways. And the same as sorting in the same way that sorting on GPUs is just fascinating. It's like, man, look at this problem that's like pretty well optimized on the CPU and yet is incredibly difficult to do on the GPU, you know? The project was for sex determined in pre-birth, like gators and gender forms pre-birth for life. Oh, interesting. Owens, I have a few other questions, answers to your question. Now, a place, but this helps finding legally accessible papers. Yes, that's a good link. It's interesting to follow through your thought process. How and why do you say it's crappy? So the reason I said it's a crappy paper is because of this. If you look at it, it's 3 pages. 1, 2, 3. It's very unlikely that you can properly cover the methodology of the paper in that time. What this probably is a quick application of machine learning to a new field, i.e. Algorithmic generation of music, also called algorithmic composition, in order to basically just create new stuff. Like, that's the whole point here. And like, it's cool. Don't get me wrong. I'm interested to see exactly what they're trying to do. I do kind of want to dive into the paper really quick because I find it super interesting. But I don't think we should. I think we should probably stick to our lane and learn other stuff that's more related. But my guess, let me just read it. Just give me a second. Please don't leave. Just give me a second. Let me just read it. Hand fingering movements are a mainstay of piano techniques. Hand and fingering movements, obviously, yeah. Automatic fingering from symbolic music data allows us to simulate finger and hand movements. Previous proposals achieve automatic piano fingering based on knowledge-driven or data-driven techniques. We combine both approaches with deep reinforcement learning techniques to derive piano fingering. Finally, we explore how to incorporate past experience into reinforcement learning-based piano fingering and further work. Okay, so my naive guess here is that this is particularly useful for people who are creating music online, or not online, but on their computer, and they're trying to see, is this actually human playable, right? That would be my naive guess here. Oh gosh, I wish... things like this kind of make me wish that my stream was just reading papers, you know? Like, that's all I did. Like, the whole stream was just me reading papers and being like, oh, this is interesting for this reason. Oh, what if this... You know, like, I love doing it so much. It's just amazing. We need audiobook papers. I think that would help certain people. But it kind of depends, right? Like, for me in particular, the reason I don't usually read papers on stream is because paper reading, when I have to read it aloud, is incredibly slowed down, right? Like, I have trouble reading out loud. I actually have trouble... It's not like I have dyslexia or anything, but like I can't read a word fully. Like the word fingering, I don't actually read the word fingering. I read the first 3 letters fin, and then I guess from the length that it's the word fingering, right? Which is why you hear me sometimes when I'm reading things aloud, you'll hear me like mess up sometimes for words that have like kind of a messed up end. Or could be 2 different things. I just kind of guess as to what the word is, because like I genuinely can't read a full word. I have to just kind of look at the start and guess the word based on length. And so, like, for me in particular, reading out loud is very difficult. However, speed reading is really quick. I can just look at a paragraph and be like, you know, just look at it and just kind of, okay, I get what that paragraph means, and move on to the next paragraph without ever like ingesting it into words, right? And so, like, I've been doing this since I was like 5. Like, this is just how I learned to read. Just, you don't look at every character or every word, you look at it as a whole, and then all of a sudden it's like, oh, okay, I get it. So for that reason, reading papers is super quick for me, specifically because the language is all very much uniform in a way. And so like once you get used to the scientific literature, you kind of know how it all works, and you don't have to really think about the sentence structure too much. And so for that purpose, you can kind of, it's a lot easier to speed read papers is what I'm trying to say. And so, audiobooks would not be particularly useful for me, not only because they would slow down the process a lot, and I also can't follow people speaking for that long, but also, like, what do you do when you get to figures? Like, what are they going to do? Are they going to be like, in this figure, we see test 1, trained on 1,000 episodes, test 2, trained on 100 episodes. It's like, well, how do you actually appropriately describe a figure? You know, this type of stuff. What do we have here? You can get browser add-ons to read with TTS. Oh, that's fair. Book club, but for papers. I myself like figures, though. I chose more than one Y chromosome in males. Like you can easily find more than 2X, but more than one Y I seems to happen significantly less of the time, and that is for what the project was for. Interesting. I have the opposite problem. I can't speed read. Yeah, I know. I know I'm super biased, and like the reason I find research papers so engaging is specifically because I can't follow video content, right? Like if I was someone that could follow lectures, if I was someone who could understand YouTube videos that were longer than 2 minutes, like I would probably find video content incredibly engaging. And I would never have said what I said earlier on in stream, but I just don't have the attention span to like watch video lectures and stuff like that. I just can't follow it, you know? And so papers are something I do have the attention span for, and it's something that is immediately engaging to me. Journal clubs, actually. Yeah, the problem with journal clubs is like everyone's supposed to read the same paper and talk about it all at the same time. Again, they have medication for that. Yeah, to be fair, maybe there is a bit of like dyslexia or ADHD or something in me, maybe. But I feel like I'm functioning pretty well. Just because I can't watch videos doesn't mean anything, you know. My grammar is so bad when I type fast things I get messed up. No, don't worry about it. I think I understood what you were saying, but like, you feel free to type it again and I might understand it better. Hey, Bored Spaghetti, how are you? Okay, we were talking, I don't know why we were talking about that. Oh, right. Someone asked, how do you find papers? And I went on a tangent about piano fingerings with reinforcement learning because I went to the archive. So, let me actually just do a full rant on this. Journal new page before. We're going to say open papers. Okay, I love this topic so much. I'm functioning pretty well. I love the topic of open papers because literally everyone, okay, not literally, almost everyone in the scientific community wants their research to be open. The reason it's not open is because they have to publish their papers somewhere, and those journals do not want the research to be open. So this means if you find a paper, more than likely it's behind a paywall, which sucks. Like everyone agrees that it sucks. It shouldn't be behind a paywall, but it is, you know? So how do you find papers that are not behind a paywall? And my first place I always suggest people to go to is the archive. So the archive is a list of pre-published papers. These are papers, pre-printed papers. These are papers before they undergo peer review. And oftentimes, if they're published on a preprint server, they're also able to be published at the same time. So what you can do is, if you find a publication, you can look for the archive version of the paper, and a lot of times it will be up and available. In certain fields like physics, it's always available. You want science to be available to people? Journals want people to pay for science, right? Now, again, these are not peer-reviewed, which is why you'll sometimes get papers that aren't particularly good. But like I said, I enjoy reading bad papers as well. So the next place to find like open papers is to go to Google Scholar. So if you go to Google Scholar and you type in literally any paper, here's just one that I have right here. Let me just efficient histogram algorithms. All right, so here's a paper I had just next to me. You'll see there's a PDF by psu.edu. Just click that. You know, that's the next way to find a paper, and it's probably the way that I would recommend doing. Let me talk about a few other things here before going any further. One is that Google Scholar is particularly useful because you can look at forward citations of the paper as well. So this guy was cited by 144 people, and one of these was cited by 440 people. And in general, you can tell the quality of a paper based on the number of citations that paper has. Now, this isn't always true, but if a paper is very highly cited, it means that it's generally trusted in the academic literature. We looked at a paper earlier that had only one citation and didn't have very many references. And I kind of didn't trust that paper because it didn't look like it was being used for anything, right? But this paper here has hundreds of citations. So I know a lot of people found use in this paper, right? More than that, you see a lot of other papers that are kind of spawned off the same idea. And so for that reason, I can kind of trust this paper, right? And this was like the original paper for efficient histogram algorithms on CUDA devices and stuff. Now, about the archive. So someone else mentioned that they don't like reading papers because it's all kind of bland. And I think it's really important to talk about the archive, right? Because it in some sense solves this issue, right? So for me, when I started reading papers, I didn't know what fields were interesting. So I looked here and I said, I'm kind of interested in physics. And so I clicked on new in physics. I'm kind of interested in math. So I clicked on new. And then I also looked for example, algorithms, right? here, data structures and algorithms here. And then I'm like, well, I'm interested in computing, so maybe here as well. And you just kind of click any of these keywords that you find kind of interesting. And then what you do is you go here and you just look at the titles. You're like, which of these are interesting? Which of these do I look at? And I'm like, wow, that's amazing, right? A topological photonic Sue-Schrafer-Heeger type coupler. I don't know what that means. What is this? I have no idea. Multi-phase flow applications of non-intrusive reduced order models for Gaussian process elimination. That one actually sounds kind of interesting. I might like that one, you know? Then we go here for mathematics on the Chow ring of the classifying stack of algebraic tori. Again, I don't know much about this field. At the boundary of Minkowski space. That sounds interesting, right? Then you go to data structures and algorithms, improve bounds for scheduling flows under endpoint capacity constraints. Might be interesting. Hyperbolic computation through dominating sets. Now that one sounds interesting, right? And then you go to computer science here. Let's see, what do we have here? Sorry, I missed this. How do you ensure papers are open on Google Scholar? Really, the way you do that is just check the PDF link over here on the side. In general, that means that there is a free version of the paper available. If you don't have a PDF link on the side and it's not available in the archive, then you need to use some other methods that were mentioned here in chat. For example, there's like an open website. I don't remember it, but someone posted it earlier. Let me see if I can find it. Unpaywall.org here is a good one. There's also a website that rhymes with CryHub that people will use. Okay, it's called Sci-Hub. People will use it a lot. I'm not recommending you use it because it is technically illegal in the same way that torrenting stuff is illegal. So I don't recommend you do it. But if you have no other option, I don't think anyone would be mad if you did. You can also email the authors. Remember that scientific authors, people who are publishing papers, don't get paid to publish. Often it's the other way around, where you have to pay almost $2,000 for the paper to be available. And yeah, so it's if you ask the author, they'll usually give you the paper as well. Retype. I chose more than one Y chromosome in males. Like, you can easily find more than 2 X chromosomes, but more than one Y chromosome seems to happen significantly less often, and that's why I chose to research for my project. Interesting. Actually, that is interesting. Why do you see more than one X chromosome more than you see more than one Y chromosome? Oh, that makes sense, I guess. Right? Yeah, I guess that makes sense, because you'll always have an X chromosome. It's always X or XY. So you should have, if you have an extra chromosome, it's 50% more likely to be an extra X, 75% more likely to be an X than a Y. I don't know, I'm making that up, I have no idea. Because we had to choose a topic from research to research from literature. Sorry, I missed this. How do you ensure papers are open on Google PDF? So you usually open papers you have no idea about, or rather start with something that you're least familiar with. Female is XX, right? XXY is I know that it's like one of those diseases that you can get, but I don't know which one. But I think you said you're looking at XYY, right? As far as papers that I talk about, or I like, in general, again, I've been reading papers for a long time. So like when I go here, I see a lot of things that I find interesting. Like, for example, copy detection. For me, I'm like, oh, I know copy detection. I'm interested. What are they talking about? And then they say bag of tricks. I'm like, I don't know what a bag of tricks is. So I will click on papers that have like one thing I know about and one thing I don't know about. And so, like looking at the physics papers, let's go there, because I know less about this topic. So here we have a topological photonic Sue-Schrafer-Heeger type coupler. So of the words I understand, topological, photonic, and then coupler. I don't know what this is, but maybe I want to learn what this is. Depending on the day, this could be clickbait or it could not be clickbait. It depends on what else is there, So I really like, basically, I click on anything if I kind of feel like I know a little bit about the topic, but I don't know exactly what they're doing. You click on it for the same reason you click on YouTube videos, right? Like, if you see a thumbnail you're like, wow, okay. Or you see a title you like, it's like, oh, okay. I'm interested in this thing. So for me, like, it just kind of runs the same way. There's certain keywords that I'm like, okay, this could be quite interesting. So looking at the physics here, I know about multimode optical fibers. I should know about GRIN. I've heard of it. I don't know exactly what it is, but statistical mechanics of beam self-cleaning, I'm like, oh, okay, that could be interesting. What they're trying to do here, I think, is basically take a laser, couple it into a multimode fiber, and then have the beam come out the other end like super clean. That's my guess as to what they're doing here, and they're trying to basically describe the laser propagation through multimode optical fibers, probably in an experimental way. That's probably what they're doing. I don't know for sure, but yeah, maybe. So guerrilla science, creating scientific instruments in high tropicality conditions. This one, for example, is not interesting to me. And the reason it's not interesting to me is because of this line right here, guerrilla science. If they would have said creating scientific instruments in high tropicality conditions, I would have been like, actually, that's quite cool. When you think about it, my guess is that this is creating robust instruments that work in like the Amazon rainforest and stuff like that. But because they wrote guerrilla science here, now I feel like, okay, probably there isn't too much to be learned here, right? Probably it's going to talk about historical methods, and I'm just not interested in that, right? This one down here is also equally unclicky, like falling atoms. I'm like, okay, what does that mean? I don't really care. And the fact that it's like by one author kind of leads me to believe that maybe it's not particularly well like put together, you know? At what point do you decide if it's worth printing out and reading? From the title, abstract, or a quick browse through the whole paper? So you're saying the title is important. The title is the thumbnail, right? So you can think of it like as it's the most important part of the paper, I would say. It's the click thing. Like that's the thing you're clicking on. So the only papers that you're going to come across are papers that you find on the archive, or papers I come across are ones I find on the archive, and I click on them because they have a very clicky title, or papers that have been recommended to me by other papers, right? So that's where I find papers. The question is at what point do I find them worthy of printing out? Well, I find them worthy of printing out if one, I've read the abstract and I feel like there's something important to talk about there. But two, sometimes I'm like, this is a cool title. Let's just print out, see what's happening, you know? Like it just depends on the day. It's the same as videos. What makes you click on a YouTube video, you know? Here's a question. Would you rather have a flashy, catchy title or one that perfectly describes what you're going to find inside? The ones that perfectly describe what you find inside are the flashy, catchy titles. That's what you want. Do you have a video on how to write a good paper? No, I do not. A/B testing for article titles incoming. Look, I mean, people have already been doing these testing for years, right? Like people have been looking at this for decades now. People know what will get you to click, you know? And that's why I said down here, this guy in principle is, you know, they tried to be clickier by adding this guerrilla science. But what I was interested in is creating scientific instruments in high tropicality conditions, right? And so if your title does accurately describe the topic at hand, then I'm probably going to like it, you know? However, there are some times that I get a little bit frustrated, you know? Like, for example, if I'm super interested in parallel processing, right? Let's say specifically GPU engineering, and a title says, hey, you know, here's a paper where we GPU accelerate a particular method, or GPU acceleration of, let's say, photomosaic generation, but they don't GPU accelerate the sorting part, which is the part that's actually slow and the part that I expected to learn about, how to optimize that particular part. Then I do get a little bit upset. I'm like, man, I thought you were going to talk about this, but you didn't, you know? But also, like, I just read so many papers, like, fine. I don't know how to put it, but, like, there's something about just, I don't know. It's fine. If the title doesn't perfectly describe the topic, I don't get too upset, but I prefer if it does explain exactly what it's supposed to do. Like, it's super disappointing to get into a paper and then realize, it's actually talking about this when you were expecting that, you know? Because when you see the title, your mind immediately is like, oh, this could be quite cool because of this reason, right? And then you realize, oh, wait a minute, it's actually not what I thought it was, you know? It was interesting just that the project took me a long time to do. I had to find all the literature, then I had to read the literature, create a presentation on it. It took me a long time because I had to read like 5 papers that had a lot of terms I did not know. So I had to do a lot of side research just to understand the literature. Yeah, this is the other thing too. Like, you know, when people talk to me about Linux, you know, I am super biased towards Linux. And the reason I'm super biased towards Linux is I've never used another operating system. You know, like you could argue I've used Windows before, but the last Windows version I used legitimately was Windows Millennium Edition. You know, I technically had Windows Vista installed, but like, frankly, I never used it, right? Like, we're talking about long time ago, man. Like, it's been a long time since I used Windows. I technically used Mac for a year during my PhD, but I only used it for a Linux device because I was SSHing into a cluster. So when people talk to me about Linux and they say, oh, it's too difficult to use, I'm like, I fundamentally can't think of an easier operating system to use because I'm so hyper-focused on it. It's the only thing I know how to use, right? The same is true for research papers. I've been reading research papers for so long that, like, when people are like, it's dry, it's hard to read, these are things I can't, like, I get it. I remember back to when I was in high school, and I remember back to reading a book. It was Electroencephalography, Basic Principles, Clinical Applications, and Related Studies by Ernst Niedermeyer. Let me just go ahead and pull it up. This book, I loved this book so much. Man, did I love this book. This is not the one I had, but it's essentially, let me just, maybe I can find it on Amazon. Let's do EEG. What? Come on. What? Egg? Is that what I think I wanted? Electroencephalography. Here we are, something like this. So the truth is, I think this is the one I had by Niedermeyer and Silva, but it's changed from there. But I'll click on this one because this is the one I had. Between that book, and again, I hate to say it, but this is actually the other book I was researching. This guy right here, my International Interlinear Bible in 3 different languages. Man, these were my jam. I loved reading things and knowing that there was something out there that people didn't know yet. There was something about it that just really just scratched, I don't know, behind my ear, whatever you want to say. It was just something about this book consistently saying in the book that this topic, whatever they're talking about, is an area of ongoing research was just super cool to me. And the Bible was the same way. It's something about, reading this ancient text that people still, believe for some reason, and trying to figure out exactly how it was worded in this way and how people could, make it match modern society. It was just an interesting question. I was like, how does this actually work? How can people possibly believe X and Y at the same time? And, non-Christians are like, it's because they're stupid. They just believe anything. But there's more to it than that, something about digging deeper into the text was super interesting in the same way that digging into this text was super interesting. And I don't know. Sure, there were a lot of words I didn't know. I didn't know what a glial cell was. I didn't know what a neuron was, for Pete's sake, really. I didn't know what the axon was. I didn't understand, how an action potential worked. There were all these things that I learned in the first chapter that I just circled, and I tried to figure out. My notes for this book were insane. And I remember doing that. And I remember loving every minute of it, genuinely loving it. And I think the reason I loved it so much was because it wasn't forced on me. It wasn't something I had to do for class. It was something I was doing for fun outside of things. I just wanted to learn more. And in that process of just wanting to learn more, I never had that stage of being burnt out by a class, It was something that, I could just do on my own time whenever I had it. And I think that's something that's really important. One of the biases that I came across during my PhD, sadly affected me a bit, was that one should only read peer-reviewed papers. Now I'm thinking that's not a healthy mindset. So there's actually a lot of unhealthy mindsets I came across during my PhD. Some people were saying that you should never do what other people have already done, as in you should never replicate a study. That's something that one of my professors told me. And I don't vehemently disagree with that. There's a lot of truth to that, right? You shouldn't recreate other people's work because it's going to take weeks to do, months to do even. And in the process of doing it, you're probably not going to get anything from that research, right? Because that area has already been done. However, there's a key other side of that story. That is replication of scientific, of any research is a cornerstone of the scientific method. And in order to build on that work, you should properly replicate it, And so, for example, in some of the stuff that I'm doing now, I genuinely know, I'm almost positive that we can beat some of the existing methods for photo mosaic generation. But I need to implement those methods so that we have something to benchmark against. Replication is also great for learning. That too. Isn't that a master's job? Right, could be as well. There was one other thing I wanted to say. The other topics that people didn't like, I just didn't agree with, as far as peer review study and all that kind of stuff is concerned. For me, like, this goes back to my philosophy that, like, I've never met a paper I don't like. I just saw an archive paper. You saw it on stream like 20 minutes ago, where we opened a paper that was just like meh. It wasn't a good paper. Like, you could see immediately that it wasn't a good paper. But I think it has merit. You know, there was a paper I found a long time ago and I never found it again, and I've been searching for it, but I can't quite find it because I think it was removed from the archive after it was put out. But it was literally of some guy who was trying to find the magnetic, let me try to explain this in a way that makes sense. So if you have a wire, right, and you have current going along the wire, you have a magnetic field that wraps around the wire, right? This is a known physical effect, and it's how you create magnetic fields. I'm not going to go so much more into it than that. So what this guy was doing was he was saying, okay, let's say we don't have the wires, but we only have the magnetic field. How then would you go back to find the wires, right? And it's actually kind of an interesting question. How do you do that? It's not so difficult to do, right? I mean, you take a curl and you basically figure out where the curl's zero, blah, blah, blah. But how do you do that efficiently? That's the question. This problem is directly the same problem I had in my superfluid research. And I found it on the archive one day. And I was like, oh, that's a super interesting paper. And I read it, and I was like, okay, their methods weren't particularly great. But the question was amazing. Like, this question really did help me think about how to, better solve another thing, right? So, like, sometimes you're not really looking for a paper for replication. You're not looking for a paper to work off of. Sometimes you're looking for a paper for inspiration. Sometimes you look at a paper and, like, for example, going through the titles in the archive, this gives you a good idea of, like, what the people in the research literature are interested in. What do they actually care about? Why is this interesting as opposed to that? Why are people doing this thing? Because if someone took the time to write a paper on this topic, they clearly care about it. And why? Why do they care about it? Is it leading up to something bigger? Maybe it's not. Maybe it's just they're trying to get a paper out for the publication economy. Who knows? The fact is, there's a paper on this now. And, someone's interested in it. And someone's solving this problem. And you have to wonder why, And that's part of the whole process, right? So yeah, a bias towards peer-reviewed paper. Yeah, I mean, obviously you don't cite non-peer-reviewed work. You don't cite a paper that has not been appropriately published, right? You don't do that. You'll cite software that way sometimes, but never papers, right? But certainly using the archive work for inspiration is totally fair game, I would say. In fact, I recommend it. I think that's the number one way for people to kind of learn what fields they like. I learned that I'm super into computation because I just clicked around papers on the archive. That's what I do. I learned I really like this thing because every time I started, like, looking at the physics papers, I found myself, liking them, but not liking them so much, and then slowly but surely honing in on the computational side of things and realizing that's what I actually really liked, and it's just, the only way to do this is to, gain experience, everyone hates, I always love comparing this to video games because it's just so much like a video game. And everyone just kind of disagrees with me, but, like, you pick a class, like, you got your biologist, your chemist, your physicist, but, fine, that's where you're at. But, like, you can spec out that class in any way you want, you're your own person, just read papers in a field and just kind of gain experience, keep leveling up, your biology side, your physics side, your chemistry side, keep, like, learning more things. And the more you learn, the better of a researcher you are, the higher level you are, the better you are at reading more papers. You just have to get through that grind. The early level grind is always the hardest. And it's just, I don't know, for some reason, like, it really bugs me because, like, in Guild Wars, I had like 3,000 hours in Guild Wars. It was insane. And most of that time was grinding for a single title, 1,400 hours for one title. Admittedly, it was all AFK time, but the fact is, I spent a long time getting this title. And you see people all the time who are super willing to just waste so much time on video games or on whatever they're doing, TV, for example. And they don't realize that time spent, you're basically grinding. You're not really enjoying most of that time. but there's always like a spike of enjoyment at the end or somewhere in the middle or something like, that keeps you going. And it's the same thing for papers, right? You kind of just have to get through that grind. And there will be something in there that you're going to enjoy. But, as you start learning more and reading more, it becomes more and more enjoyable. I think the big difference is that, watching television is very much a social thing. Playing video games is also a social thing. Whether people are playing the same game that you're playing or not, the fact is, other people are playing games, and you have that social element that keeps you going. And the only social element that keeps you going for paper reading is academia, which sometimes people just flat out argue you shouldn't read papers. Like that's what people at MIT told me, which is why, again, I was just probably super depressed at MIT. Motivation is a heavy topic in psychology. There's a project that I'm working on that may be able to be published. I'm trying to take a 3D model and generate 2D vector graphics, SVGs essentially. How exactly are you doing that? Are you compressing it onto 2D space via like some sort of projection mapping? I feel like I've seen a lot of papers in this style. In particular, some of the stuff I was reading recently was taking basically an edge-detected image, not canny, but something like canny, and turning that into. In fact, let me just see if I can find it. It was another nice paper I read recently that I was like, oh, that's actually quite clever. It's going to be in this stack. Let me just find it for you. It's not the same as what you're talking about, but it reminded me of this one. I believe it's not structure, but is it structure based? No. ASCII art synthesis from natural photographs, I believe is the one I'm looking for. Scholar ASCII art synthesis. I'll probably find it. Yes, this one. I like this one a lot. And I'll explain why I like it. I can't draw, but I want to be able to create 2D images, but I can 3D model. Yeah. I know exactly. Yep. I have a very similar problem, where I've always been interested in the creation of, in some sense, computational art, right? I'm going to call it computational art. I don't know if it should be called that, but the creation of art through purely programmatic means, but not necessarily CGI. Like, can you draw an anime character appropriately just by using, vector graphics? How would you automate certain processes? How do you do the hair? All this kind of stuff is quite interesting, Let me do Zernal PP, ASCII, downloads. ASCII art, one second, art synthesis is what I'm looking for. Anyway, this is not exactly what you're talking about. In fact, it's not what you're talking about at all, but it reminded me of this paper. Again, I was really into ASCII art recently. Basically, if you take a butterfly, let me change the color here to be black or something. You take the butterfly here and you recreate a structure like this, right? What they did, and this is the interesting part, is they actually, if you do a canny edge detection, you end up with this image in here, right? Which is not very good, right? So what you need to do is you need to actually create a feature detection as well on top of the canny edge detection so that you can remove all the features that you don't need. And they created a feature generator that basically, I'll do this in blue or something, that basically created the exact edges that they needed and then converted this into a form that could then, basically be turned into ASCII art. I thought it was quite nice. I was like, wow, that's amazing. If you combine this with some shape matching, I was like, ooh, that's cool. That's super cool. Anyway, the main thing was they talk about how they do this, and the main problem here is like kind of, in a sense, you could call it stroke ordering, or trying to figure out exactly like what direction each line is going in. It's actually useful for some other features and stuff, but we can talk about it later. It's been a while. Like I need to refresh, but I read this one early last week, so I don't remember all the details. Oh, but this one was also cool. They talked about psychology and how, like, people only recognize certain bits of the image, so you can actually blur other bits, and that's how their feature detection worked, by kind of working off of a different psychological model. I was like, wow, it's amazing. Anyway, I got really into it. You just describe a demo scene, really. Multiple SVG objects for different parts. Outline of the object is one object. The shadow is another. Just spotted Gabor filter. Yeah. I to be fair, I didn't know much about this at all. And then I was like, ooh, that's cool. That's my problem with papers. Like, every time I read a paper, like, look, you guys are right. You guys are totally right in saying that some people don't like papers, but for me, it's just all clickbait. It's like I'm in the middle of a paper and I'm like, oh, look at that. Oh, it's amazing. You use that for that? I'm like, wow. And I think it's because I I know so many topics now, or like at a surface level, that when I see, for example, shape matching in the middle of a paper on ASCII graphics, I'm like, ooh, do tell. Like, how did you do that? I don't have to look up shape matching because I know about it, right? And so it's like, it ends up becoming this thing where it builds on itself and it becomes more enjoyable the more you do it. Indigo quiz does painting using implicit surface definitions. Oh, yes, this is the video I was thinking of. I know which video this is. I'm almost positive I know which one it is. It's quite cool. This is the one, yes, with the girl's face. Yeah. I thought this was quite cool. Grant actually showed me the video. I was hoping. Anyway, I thought it was quite cool. It's neat. I'm stuttering a lot. That's okay. Let me go back. Okay, we ended up ranting about academic papers all day. I'm so sorry about that. I'm going to keep going. I'm going to try to find a good parallel implementation of octree generators on the GPU. And might be that's what I do. Maybe I'm just looking for that paper today. I get the paper, I read it, and then we do the implementation tomorrow. That might be what we do. It's, 6 o'clock p.m. my time. I haven't even done the algorithm archive stuff for today. I'm just super behind. But I don't know, like, I was thinking about this yesterday. Of the streamers that I watch on Twitch, like Kit Boga, for example, has an amazing job. He literally just wakes up, and like he scans for scammers. He does a lot of work there, but his stream is just amazing. Like he generally can just talk to people and just just do impromptu, discussions to scammers all day. It's amazing. Like his job is great. And I was like, man, if I could just like wake up every day and just like read papers and just talk about the papers I read, that'd be super cool. Why are you sorry? I've learned so much today. Got so much value out of your stream. Thanks. Happy to hear that. I'm just sorry because that's like my catchphrase, all the other superheroes, like, All Might is like, oh, Boku ga kita, I'm here. Mine is, I'm sorry. So like I break through a wall and then I'm like, oh, I'm so sorry. Like, it's just my catchphrase, I also almost got published in a completely different field in 11th grade. It was in botany. And honestly, the reason I did not end up publishing was because I was too lazy to work on the paper over summer break. Oh, interesting. That's actually quite cool. Okay, so this k-means clustering scheme that we saw earlier, which I couldn't find on Google Scholar, which was a bit weird. Does actually have a few citations down at the bottom. It might have been published somewhere else and I just didn't see it. But it looks like, yeah, they're using color image compression, using quantization, thresholding, and edge detection techniques. I was hoping for parallel implementations, but this might be something we want to read. Unsupervised segmentation, probably not what we want. That's using machine learning. Histopathological image analysis using model-based intermediate representation of the color texture. Follicular lymph node lymphoma grading. Okay, that probably is also not what we want. It's probably too biological. Fusion of color edge detection and color quantization for color image watermarking using principal axis analysis. Again, probably not quite. Variance-based color image quantization for framed buffer displays. Maybe. Maybe. Let's take a look at that one. Color quantization of images. I think this is just an old one, like 1991. I think we already know that one. Efficient statistical computation for optimal color quantization. That's what I want right there. GPU graphics gems. Perfect. That's what I'm looking for. Effective initialization for k-means. This is what I want. Efficient statistical computation for optimal color quantization. Let's go to Scholar. Efficient. What is it? Statistical computations for optimal. For color. Let's just see if this picks it up. Did not. Okay, let's see what I missed. Efficient statistical computations for optimal color quantization. Efficient statistical computations for optimal color quantization. Here we are. Graphics Gems 1991, cited by 137. It is not available. Or is it available? View PDF? Come on. Access through California? No way. I knew it. Okay. we're going to have to find this paper elsewhere, which sucks. This is the one we need. So what's the problem this paper is trying to solve? It just got here. So that paper, right, so what we're trying to do is find essentially this paper, Efficient Statistical Computations for Optimal Color Quantization. The reason we want this paper is because we're trying to find an efficient implementation of octree generation on the GPU. That's what we're looking for. I also missed a lot. Oh, okay. This is a great stream so far. I'd love to see more like this. I went into high school called biotech. It's in Miami. What's the problem with this paper is trying to solve? This was part of the pitch for the school. That student can be a real scientist, so you can publish. Oh, interesting. So many good papers in the Graphic Gems book series. Oh yeah, a lot of good ones. The book itself is probably cheaper than the article on the publisher site. Yeah. I bet you're right about that. Okay, so this is where it was not 100% true, but that was mostly because it was public. It was a public school in Florida, and Florida public school system is, oh man, I was from Alabama. Like, I know about bad public school systems. Trust me. I need this paper. I want this paper really bad. Yeah. So I'm going to find this paper somewhere online, and I'm going to read it. I'm pretty sure it's not going to be available. This volume isn't. Okay, so, it's evolutive strategies for adaptive color quantization. Interesting. Agree. Okay, I'm interested in that one as well. Okay, I'm going to get this paper. I'm going to read it. And I ask that you guys don't ask where I got the paper from. I'll be right back. Actually, I'm going to probably close stream so I can read the paper on my own. Let me think. What do I actually want to do here? I could do an algorithm archive PR, but I feel like I want to do that tomorrow. I've already been streaming for about 3 hours. This might be a good place to go ahead and close for now. I'll get through the paper, try to see if I can find a better, actually, you know what? Here's what I'm going to do first. I'm going to look at forward citations. Color quantization by dynamic programming and principal analysis, adaptive color reduction. A color reduction may be what I actually want to do. Let me see if I can find anything from 2017. Color image quantization using shuffle, frog, leaping algorithm. See, this is the thing. Like, anytime you dive into these, you realize there's so many other papers to look at. Evaluation of quality measures for color quantization. Let me see if I can just do GPU in, What criteria do you need to decide if a paper is good before you read it? Is the number of citations the important metric, or the specific author publisher? It's kind of a combination of both, right? Like I said before, having a high number of citations does not indicate that the paper is good exactly, but it does mean that people are using the paper for other things, right? So it means that, if like the paper we just found had 137 citations, that means that 137 people also wrote their own work, and it was somewhat related to this person's work. And they thought the paper was good enough to include in their own paper to recommend, right? So that means you can be fairly certain that the paper is decently good, right? But even if a paper has 0 citations, that doesn't mean it's bad, right? But what I was looking for in particular was kind of like the seminal paper, the paper that kind of got people started with parallel programming for color quantization. That's what I was looking for. And it looked like that probably was the paper that I was looking for, because there were 137 citations. It was on the exact topic I was looking for. It was in GPU Gems, which is a journal that has a lot of really good papers in it about GPU computing. And so I was like, okay, well, not paper journal, it's a book. But basically I was like, okay, this is probably exactly what I'm looking for, However, there are now all these other forward citations that also seem quite interesting, like efficient palette generation method for color image quantization. Maybe this is actually what I'm looking for. I would bet that this actually talks about GPUization. Let me just search for GPU really quick. It probably does, right? GPU? Of course it's not found. Let me see if I can find it here. Let's look at the HTML, I guess. It's open access though. Download PDF. Here we are. Sure, and we'll just open this up in, okay, well, it's over here, but let me just check it really quick. Here we're gonna look for Control F and GPU. Okay, so they don't specifically talk about GPU methods here, but efficient method, generation method for color image quantization is still interesting enough. Let me see what we can find here. I'm gonna download it again because I forgot what it downloaded as. APPL SCII. So let's go here to Ocular Downloads APPL SCII. And let me just look at this really quick. What I was hoping for was someone who talks about like shared memory usage and stuff like this. I was hoping for someone who gives me like a kind of more deep insight into how to actually use GPU architecture for this. Let's see, what do we have here? This article describes an efficient method to generate color palette for color image quantization. The method consists of 2 stages. In the first stage, the initial palette is generated. Initially, the color palette is an empty set. First, the end colors are generated according to the data distribution of the input image in the RGB color space. Then one color is selected from the end colors, and this color is added to the initial palette. And the step is repeated until the color number of the initial palette is equal to K. In the second stage, quantized image, the quantized image is generated using the fast k-means algorithm. Okay, interesting, k-means. You're not good, just useful. Right. So the problem is they don't have the word GPU in here. But let me do graphics. Graphics gems. Yeah, that's the only place it's used. But it's in 2021, which is quite interesting for me because that means that not only is it in 2021, but it was published this year in 2021, and it already has 2 citations, which means that this is a field that people are actually actively interested in, which always gets me excited because it means if you could do something interesting in this field, people will care about this thing that you're doing that's interesting in this field. Yeah, the only problem is, like, doing color quantization is like, it's one of those things. It's like, who cares about color quantization, right? Like, I care about it. Other researchers care about it. But it's quite hard to make this something that people care about in general. And I already have a video on color quantization on my channel anyway. I mean, look, I could redo the video. I could do like, hey, we have the fastest color quantizer or something like that. Fine. But like, you know, it's like kind of, you gotta play to your strength. Color quantization is so cool. I always love color quantization. Admittedly, all these graphics look the same though. Yeah, they always use the same images. It's always Lena. Always Lena. I was actually thinking about in some of my videos or some of my papers, like just doing the same exact, like literally getting a fluffy hat and looking back, you know, at the camera, like doing, you know, whatever she's doing, this thing, and like just taking a picture of myself posing as Lena and going from there. Isn't it just interesting because it has a lot to do with how we perceive things? Who was the first one to use her though? To be fair, like I don't know a more iconic person in data compression than Lena, and I don't know who was the first person to use it. But if we just do Lena data compression, we'll find something. So the reason I believe, and I'm not sure, but the reason I believe that color quantization is so useful is because it is it's a naive implementation of an octree on parallel hardware, for example. And that naive implementation of an octree is also useful for a lot of other methods, like, for example, the Barnes-Hut method and all this kind of stuff for galaxy simulations. In fact, when we did the initial video on color quantization like 4 years ago, we were specifically interested in galaxy simulation at the time. It's just that we couldn't really get a galaxy visualization out in time, so we said let's just do something else. So it looks like she's from 1972 Playboy. Interesting. In 1988, she was interviewed by a Swedish computer-related publication, and she was pleasantly amused by what had happened to her picture. Apparently, it was used in 1973. Interesting. So Alexander Sawchuk estimates that it was in June or July of 1973 when he, the assistant professor of electrical engineering at USC Signal and Image Processing Institute, along with a graduate student, and the SIPI lab manager was hurriedly searching the lab for a good image to scan for a colleague's conference paper. They had tired of their stock of usual test images, dull stuff dating back from television standard works from the early 1960s. They wanted something glossy to ensure the good output dynamic range, and they wanted a human face. Just then, somebody happened to walk in with a recent issue of Playboy. Really? People just read Playboy? Really? Let's see. Someone's paper should just be named Always Lena. Why this picture is always used in research. I'm sure Wikipedia has the whole story. I should have just read it on Wikipedia. This chat is going to publish that paper. Somebody happened to walk in with a recent issue of Playboy. That's like one of those mythical stories that you hardly can believe. It has to be crazy. Somebody happened to walk in with a recent. Also, I have a question. What is this emote used for? Like in general, I know what lol is used for, but what is that emote used for? Does it mean you don't, you're bored of the stream content? If so, cool. Feel free to go to another stream where we're not talking about a Playboy girl who apparently is the face of data compression now. It's super cool, but it's not everyone's content. Feel free to go somewhere else. Oh, let's not click there. Maybe he's tired of Lena. That could be true. She's in every paper, which is totally fair. Fractal image compression. Of course, fractal image compression is the first thing that appears. It's so cool. But anyway, let's not talk about that now. What are we going to talk about next? I want to see if there's a better paper for me to find for the color quantization story. That's what I want to see. Kappa is a joking one. I thought Kappa was sarcasm. Sarcasm. Sorry, I'm just tired of the Lena. Oh, that's fair. Again, she's in every, that's what I was saying. I think for a paper, if I do a paper in this area, I kind of want a picture of me that looks like in the Lena pose and use that instead, because I kind of feel like it's a little bit, I don't know, it's weird that all the data compression, JPEG images, everyone uses the same image, it's just kind of weird. And then there's PogChamp and other stuff. Yeah, what does PogChamp mean? Kappa is yeah, right? Please, no naked shoulders. Sure, I guess. I don't really know. Let's go here. I'm looking for, yes, efficient statistical computations for optimal color quantization. This one looks promising. It doesn't mention parallelization. So what we might want is, let me just look up parallel color quant. And let's see what we got. Ization. Local parallel cross-platform color texture distributor for image traversal, color quantization with particle swarm optimization, and artificial ant. See, that seems like one of those papers that it's in 2020 though, really. 2020. Color quantization process attempts to reduce the number of colors. Oh, because I say since 2017. An adaptive cartoon-like stylization for color video in real time. Okay, I'm looking at this one. I'm sorry. We want to download the PDF. I can just look at the HTML for now. Where are the images? What do you mean cartoon-like? What is a cartoon-like color scheme? Oh, here's an implementation using CUDA, which is nice. But give me some images, man. Okay, here we are. Is this actually what we're looking for? Maybe. You can call your version Leno. Yeah, maybe. Let's see, what do we have here? Let me go up. Okay, look, this is going to give us a fast implementation. The cartoon-like stylization of color video images is one of the major types of non-photorealistic rendering. Ooh, it has broad applications in the entertainment industry due to its lively style, flexible form, and autonomous creation. Our video cartoonization framework consists of color space conversion, bilateral filtering, color quantization, and edge detection. We're going to have to do all of those anyway. Maybe this is a paper I want. We use an adaptive difference of Gaussian filters to detect the edges. Variance value of Gaussian filter is oof, this is a tough one, is determined based on the gradient of each pixels. There's so many typos. Like, oh my gosh, I know it's cited 5 times since 2020, which isn't bad, but it's still like, I don't know if I can trust it with all the typos just in the let's see. All right, what do we have here? New hardware architecture for self-organizing map for color vectors. Which one's a highly cited local parallel cross pattern? A local texture descriptor for image retrieval. Color quantization with particle swarm optimizations. Parallel computations. That just sounds like it's not even a fair. Man, so many papers published for color quantization since 2017. Let me do anytime and see if there's a better available. Robust parallel architecture for adaptive color quantization. This is done in 2000, so it's a bit old, but this might be what we want to kind of get started. Why are these so old? And why do we have so few citations on all of these guys? Like, why do we not have good parallel? What gets me is, like, surely there are people who are doing, surely there are people who are doing parallel implementations of color quantization, right? Like, just, I'm looking for those papers. So we have GPU color quantization, which we didn't find. Like, very many. Techniques for GPU, but this one. This is the one that we found before. Yeah, this is the one, GPU color quantization from 2010 with no citations. GPU implementation of LBG, GPU-based video stylization. I can't do Japanese. And also, you're right. I agree. What I was trying to say was, I mean, you're right. You guys are totally right. I was judging it based on the English capabilities of the writers, which is never actually fair. A reviewer's English isn't always perfect. What it's a sign of is having a bad editor, not having a bad author, right? That's what I was trying to say there, is that I'm not trusting the journal, is what I'm saying. Not that I'm not trusting the paper. That's often what it means if the English is still poor at the time of publication. Because again, I'm with you. Like, you asked me to write anything in some other language, I'm awful at that, but it just means that there is some, it just means that the journal lacks polish, is what it means. On-the-fly appearance quantization on the GPU for 3D broadcasting, techniques for GPU-based color palette mapping, maybe this one, 2019, but no publications, or no citations. Contextual algorithm for color quantization and adaptive cartoon-like stylized. Maybe that is what we want, this guy. What else do we have here? GPU color quantization, 2010? Okay. CUDA, let me do CUDA. Maybe they're all under CUDA. Who knows? Adaptive cartoon stylization, effective real-time video abstraction using CUDA. Let's see. The only time I sent something to be published in a journal, the editor actually asked me what I meant before their corrections. Right, that happens fairly regularly. So I assume editors are not experts in every field, and that might also have happened. That's probably fair. Let's see. So, okay, the truth is I'm not really finding the papers that I'm looking for. The one that I thought might be interesting is this guy. Which, to be fair, will be kind of like a seminal paper in the field. And so you kind of want more recent publications, which is why we looked at this guy on Google Scholar. Let me just look it up again on Google Scholar, look at forward citations there. And then there's a PDF here. Full text PDF. I'm gonna use this one. Let me go to Discard and let's CP downloads efficient. Where is it? What did it download as? An efficient. Here. Okay, that was here. What else do we have? Again, what I was hoping to do was also look at forward citations here. So let's do that as well. We did that just a second ago, but I didn't quite find what I was looking for. So let's go here, forward citations there. Adaptive color reduction. This could be useful. Again, 2002. Let's check from 2017. Shuffled frog, leaping algorithm. My suspicion is that these guys are already like doing it all in parallel anyway. So maybe that's why we don't see like, the GPU and GPUization like as prominent, Dermoscopic skin lesions, image segmentation, color image quantization using the shuffled frog leaping algorithm. Fast color quantization using McQueen's k-means algorithm. It looks like a lot of people are doing k-means. It looks like that might be how we're doing. Well, a lot of people, like 3 people. Evaluation of color measures for color quantization. That might be interesting. Quality measures for color quantization. Man, I just didn't realize this was like a huge subfield, Which says to me we actually have to think about like how exactly do we want to do the quantization here. The other thing too is, like I said, I kind of am on a deadline here. I don't want to spend like an insane amount of time, on color quantization methods. I feel like, we should be able to find this relatively quickly. So yeah, let me see. So evaluation of quality measures for color quantization. This is actually just interesting for my own purposes. I'm quite interested in that. Fast color quantization using McQueen's k-means algorithm. These guys might give me other papers to look at. So this one in particular, automatic submutations for, oh no, not that one. Color image quantization using shuffled leapfrog algorithm. And this guy might be interesting for their own purposes. Anonymous Cheer, thank you so much for the bit. Really appreciate it. Color quantization problem solved by swarm-based operations. Artificial ants and fireflies can perform color quantization. I think we already knew that. 2-stage method to improve quality of quantized images. This one might be useful as well. Again, we're looking at 2020. In fact, let's just look at everything since 2020. Evaluation of quality measures, we looked at that one already. Photo sequences of varying emotions, optimization with a valence arousal annotation data set. Really? That's interesting for other reasons. I'm super interesting. They're talking about emotional registration of facial recognition for. That's interesting. Fast color quantization using McQueen's k-means algorithm. Revisiting an iterative ant tree for color quantization algorithm. Hybrid approach using k-means and genetic algorithms for image quantization. 2-stage method. This is probably another good one. Recent applications of swarm-based algorithms to color quantization. Yeah, it's weird that everyone's doing swarm-based. Is there like some reason people are doing swarm-based methods all of a sudden? Corollary to that, if we end up using Barnes Hut or something like that, which uses a similar octree-based approach, could we use swarm-based method for solving of that as well? Okay, well, let's just see. Again, this is color quantization with particle swarm. Like so many papers on particle swarm. Oh, from the same person. Here, and... Oh, also here. You're telling me he published 3 papers in 2020 all about methods for improving quality of quantized images. Also here? What is this guy? Is that just his whole thing? Girl, I'm sorry. I was biased of me. Holy cow, look at all these publications. 1, 2, 3, 4, 5 in 2020. 2 already in 2021. I guess we're almost at the end of 2021. Interesting. Cool. Good for her. Color quantization with swarm optimized artificial ants. A mixed method for effective color reduction. Same person. Lots of color quantization. Some 2021 aren't listed because bureaucracy. Yeah. Okay. So how do we want to do this then? I got a bunch of papers I want to print out now on color quantization because of course I do. I'm going to probably go through those and then I will... Do I have my printer set up? I think I have my printer set up. I could start printing them out. But yeah, I'll probably start printing them out, going through them and going from there. You do a scholar profile reviews if we pay enough channel points. What is a Google Scholar profile review? What does that mean? I mean, look, the fact is, I really like reading papers. I'd love it if I could just if my stream was literally just reading papers. That's all I did. I don't think that, I think that'd be like an enjoyable thing to do regularly, but also I 100% recognize that people are not super into that, So, doing actual research is also a really important thing to talk about as well. Okay, so let's take a break here. I'm going to print out a bunch of papers on color quantization, and I'm just going to try to read through them and see what we actually need to do here, Like, I'm really looking for a parallel approach to color quantization, and every time I Google parallel and color quantization, I don't really find anything, so I feel like I'm searching for the wrong terms, is what I feel like. So I'm basically gonna, send these links around, probably in the paper pile is what I'm gonna do. Let me put them in the paper pile. So we're gonna do this here and go to Discord. Let's go to paper pile here, and we're just gonna paste this guy. I'm just gonna put a bunch of them here so I have access to them later. And then we have 2. Where is it? Over here. That would be this guy. There. 3. There are a few others. 2-stage method. Yep. 4. Okay. Evolving strategy, adaptive color quantization. We might not actually want that one in the end. Rest of the Lena story, we don't need that one. Nope, got that one already. Efficient palette method for color image quantization. Maybe this one this is in 2020. Let's grab this one as well. 5 here. What else do we have? Applied science, already got that one. Is this the same one? Oh, this was just a cartoon-like style. I'm actually interested in this one just because I think it's similar to what we're going to want to do, and I figure we can look into it. There. Okay, so that's going to be the papers that we found here. Let's go ahead and paste that down here. Some people do profile reviews for gaming accounts, and they tell you how to improve that kind of stuff. To be fair, I can't really tell you how to improve your Google Scholar. I mean, if you look at mine, it's not particularly great. Let me just remove the embeds here. All right. What was I going to say? So isn't parallel quantization very hard? I believe one needs a very long bin vector, that for each core. Right. So this is why I was trying to find ways to improve it. And I was really hoping, it might be that's where the GPU gems come in. Yeah, that might just be where it is. I think I've been streaming for 3 hours and 30 minutes now. I'm going to go ahead and call it for today. I'm going to check these papers, see if I can find some better papers as well. Print those out, maybe read them tomorrow morning, come back and see if or maybe we just do it on stream tomorrow. I might read through some papers on stream. I'm not sure. There's some papers I certainly don't want to read, like for example, the GPU gems article, because I know that's behind copyright. But there's a few others that I might keep, and read, like on stream or something like that. Hey, Amaras, how are you? Hope you're having a wonderful day. Yeah, I'm sorry. You just came in right when I said I'm going to, close stream for the day. But I'll be back tomorrow. I'll definitely be back tomorrow. Today was pretty good. I'm pretty happy with what we did today. I realized we were just ranting about articles all day, but that's fine. I think it's good to do. Okay. So, that is it for now. I will see you guys tomorrow. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. I'll see you guys around next time for the next episode. I basically just woken up from my nap. Oh, from your nap. Oh, I knew you were in Europe, so I was like, I just woke up. I was like, wait. Anyway, I'll see you guys tomorrow. Hopefully, it'll be a little bit longer tomorrow. Again, I'm slowly increasing my stream stamina, getting a little bit more done. We'll see if we can get through a paper on stream tomorrow, maybe off stream. I'm not really sure. We'll figure it out. And yeah, that's where we're at. So I'll see you guys again tomorrow. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. I'll see you guys around next time for the next episode of Simuleos. Bye, guys. Sorry.